Gonna wait to see if it's streaming. I'm gonna continue to work on the Buildspace, obviously, today. Think I might take a break after 1 hour and a half, but probably I'll wait longer to take a break. And I'm gonna try to stay for a longer period of time today. So thank you everyone that clicked the link. I got it. I managed to get 11 people to click the link, so very happy about that. And like I said before, I think that for my case specifically, I think it's good that the way that they are doing, because it forces you to like build more. I think I definitely would be a lot slower if I wasn't working. If I wasn't part of the build space, I was the Nights and Weekends project. It probably would take me a lot longer to build everything that I built so far. So like it's good that you puts like some pressure on you. But I think for my case specifically, it would probably be better to wait longer, but maybe not. I also think that it might be the case that I should post a lot more often on Twitter, the stuff that I'm building. But usually I don't post there because I'm not building anything that I can visually like demonstrate something, but maybe I should be posting a lot more often on Twitter. Like every time I build something and make progress on this, I think I'm gonna do that. Yeah, but the thing is that like viewing this as an official like launch, let's say, I think like it doesn't, there isn't a point to share with people because there's nothing that they can do on the thing yet. So, but I think it's good at the same time to just get into the habit of posting stuff on Twitter. I think it's better to post even though that it still sucks. Because then eventually once it's good, then people can see like the progress. I think that's very cool. So yeah. And I changed everything to post requests instead of using the WebSocket. And I deployed everything. But I'm gonna be using localhost, obviously, so I don't I don't trigger the usage on the thing. So what I'm gonna have to do now, I think I'm gonna put some music. And now I was thinking about it, like which thing is better to work first. I think that the main priority should be to make it make the UI better and like get to the point where you can actually do is actually practical and you can gain some benefit out of it, which would be like the points where the visualization is kind of like more similar to VJS, but also more efficient, and then you can put the labels and you can customize the graph. That's the point that I'm trying to get as fast as possible. But the thing is that I also have to be concerned about the sanitization of the code and the security. I think that's very important, so it's kind of necessary. And also to be able to visualize, I need to figure out how to execute the code and get the stack frames, which is going to be very hard, I think. And I'm not even sure if it is possible or not. So if it isn't possible, I think that there must be a way to do it. Like there's always a way, but it might take too long. So I think if it takes too long or if it is too difficult, then I think it's better to try to pivot and to focus more on like trying to create a very simple interpreter or compiler. And the way that I thought about this is that I can just like I can build a database of a bunch of code, and instead of giving the user the ability to input stuff, like they would pick from the database of code that I have. And then from that database, I can create scripts that reads the files and then that creates the files based on that. And I think that it should be relatively straightforward, I think, to make something that reads all the files and then keeps track of all of the functions and creates a graph that connects all of the functions and everything on the software and allows people to visualize the connection of everything, and then make the nodes that are used more often, that have more neighbors, make them bigger, and also display like which nodes are the biggest ones, display the labels. And that would allow you to, like, it would be a lot more efficient to understand what's going on when you, instead of going to the GitHub repo. The thing is, I don't know an example of a big project. Let's say TensorFlow. I know that maybe the Ethereum, the Pi version, but like the main version is Go, but I know that that's very complicated as well. But like, for example, a project like this that has all of this different stuff here. This one is tricky because there's all the other languages as well, but if it was just Python, like when you look at this stuff, you have no idea, like what should I study first, like what's the main file, how everything's connected, like what's going on. And that's the main thing that I want to be able to do, I think. It should be able to get this repository, create a visualization, and then from the graph, you will be able to see like exactly what files are being used the most and what functions and how everything is connected. So yeah. So I think for now, I'm probably going to focus on trying to figure out the backend, how to execute the code. The solution that I found, I spent a bunch of time trying to figure out how to do the import system and copy the stuff that I had from the other videos that I did way back then, but it didn't work, wasn't working. So I decided to just, because I wanted to get the easiest thing possible, just so I could display something at least when you type in the IDE. So the thing that I did was ask ChatGPT for an algorithm that captures the nodes of the abstract syntax tree and then puts them onto a list. And then I use that. And then I send the list to the front end. So right now, like, I think it works by typing anything. It doesn't need to be like valid code from Python. Anything you type is just gonna create an abstract syntax tree. And if it doesn't work, it's just gonna show the errors, I think. But this is also one of the biggest challenges with this thing, is that trying to like think about all the possible ways that people can exploit this and the stuff that they can do. Like run the open file execute command, for example, and then they can inject stuff, or they can look into the files, reverse engineer in some way. Like I don't know. Like once this grows, maybe I'll incorporate databases like MySQL or something like that, or PostgreSQL. But I think I'm gonna, for the Buildspace thing, I'm gonna keep with Flask and the deployment that I have because it's the easiest. So I think the priority is to make sure that like it is useful and that I'm getting closer to that point where you can visualize everything that is going on. I think that's the highest priority. And then once I have that, it's kind of decoupled the front end from the back end. So I can use any API that I want, any server that I want. So I might just, at that point, create another server using Django and then use that server instead of this one. But I want to use this to get the fundamentals down. I should know everything that I have to do. Yeah, so this is the main route, I think, from the IDE. So I'm gonna work on this one now. And I have to understand more how this abstract syntax tree works and how to make it so that I can execute the code. I think those are, yeah, I created this other file because I'm not gonna use this one anymore, I think. I'm gonna leave this one for the other API route, like kind of a fallback or an example template of the way that it works. And then on this one, I'm gonna try to build something that receives the input as a string and then executes the code and gets the stack frames from the execution. So I have to understand more how the AST works and how to execute the code from the string. I'm just gonna ask ChatGPT what are all the possible. Oh, now it looks like through here you can clean the conversations. There's an option here. So they changed from outside here to there. I need to really understand these libraries first. The challenge with this is that there's so much stuff to learn. Like, this is the problem. I think it's not the kind of project that is very good for nights and weekends, because... Or I should have a lot of more experience before not joining, but submitting to be part of nights and weekends, because like for my current level of skill, I think that this is very extremely difficult to do in 6 weeks. Because the thing here is that I have to understand very well how the interpreter works in Python, like how it breaks down the syntax and how it's translating that syntax in the lower level. And I have to imagine like all the possible things that can happen during the execution of any Python software. So I understand how to not only execute, but to build the visualization after. Like what data structure is going to be good for all kinds of visualization, how to decide which data structure to use depending on what code it is. It's very difficult. And how to make sure that it's safe. Also, I should be careful with ChatGPT because obviously it can give wrong information. This is very similar as well with the security issues are very similar with the way that the ChatGPT works, because it's like the way people jailbreak the ChatGPT and exploit is like in very nuanced ways, so it's very hard to think about beforehand all the possible ways that they will be able to exploit. Because you can get into a conversation and then lead ChatGPT in certain ways, and then the size of the game tree increases exponentially, and then eventually break. So the thing about this, the security of this is that, and why it's difficult is because, like, if I accept some certain libraries, then there might be ways that I'm not thinking about that the people will use that library to trigger some function from the library that allows like an exploit, and it's very hard to think about it beforehand of all the possible things that they can do. This is what makes it difficult. But maybe I'm overthinking this as well, because there should be like a way to make it work, because the Python tutor does it and other sites do it as well. So
if you want me, if you need me, I'm yours.
go create a function here first, and I'll import this file there, and I'm gonna put it to execute and comment everything out on the other one. Oh, there's also something that I have to fix, which is there's something weird going on when I put when I call this function here to update the graph based on the whatever they put on the IDE. If you execute multiple times, it just adds new nodes instead of resetting them to this empty thing. The other one seems to work, the one in here. And I think it's because the way that I'm updating here, like I was updating inside of the function before, and then I just return now and update the nodes here, but I'm still getting the same error, and that's the problem. Because obviously every time they execute, you should clean the previous graph and create a new one. So here I also added to remove the nodes when it returns, but this is just only when it's leaving the page, when the component is mounting. So it doesn't change anything, I think, when you're still on the same page. And now it's gonna change because I changed the way that it works here, but... And the thing is I should sanitize first, I think. So I should call this first. I actually... I think I removed the... or I commented out the connection to the socket on this component. So it doesn't show there anymore. I removed everything. I think that I'm gonna have a WebSocket connection, because there's a lot of things you can do, I think, with the WebSocket that would be really interesting, but I think it's just gonna be later on once I have everything, because with HTTP is a lot easier, I think. But it would be awesome if I had something that updates the graph live, and that people can join rooms, for example, and then they can change the graph in real time and see what's happening on the software. That would be really helpful. And also remove the graph, the creation of the graph from the function, the data to graph, because I think it's better. And I also thought that this might be the reason why it wasn't cleaning the graph before, but I think it's not. But it's just better to do it this way, because then you reset the graph every time you run the function. Otherwise, it just accumulates the nodes from the previous one. But maybe I'll think about this and also give the option later to... Well, I think the best thing to do is probably update, give an option to like separate to another function, then create a function on the graph that just updates the graph, and then like on that function, instead of cleaning the graph, I just add new nodes. Maybe I have to do HTTP. But I think the problem is that is not working with the function here because it's not valid code, so I have to think about that. Let me pass some actual code. I think I'm only gonna fix the selection of the IDE once I have everything else. It's not that big of a deal, I think. Should not work. The most important thing is making the visualization useful first, and also making sure the code is secure, and then I can execute. Yeah, it just returns none. That's the problem. Maybe it's because I'm not. But if the code runs, it shouldn't give the thing, so it's not gonna work, I think. Yeah, just returns none. And now it returns the frame. Go right back. Yeah, I think that this is gonna be the way. I think there isn't any easier way. The file way I think is the easiest one, but it doesn't seem very good. So I think what I'm gonna have to do is combine AST and execute to do it, but I think it's better to separate into two different files. The first one I use to sanitize and make sure that there isn't anything on the code that can exploit. Then the other one I combine AST with execute to execute the code and get the stack frames. I think that's the first thing that I have to figure out. Then once I figure out how to execute and get the stack frames, then I can focus on the visualization. I think what I'm gonna do is I'm not even sure if I'm gonna improve the one on 3JS. I think I'm just gonna leave it like that. But what I'm gonna do is just create another component, and then I'm gonna use Pixie, and I'm gonna do it from scratch. And I'm not gonna use the useDrag hook because it's not very good. I also have to implement the physics engine and figure out how to customize the thing. So it's probably gonna customize with props from the parent component. So I create a component that just loads the graph, like in the same way that I did with the other folder. Can make like pixie nodes or something like that. The problem is I think I can't get the stacks from the execute. But maybe I can get from the AST. I'm gonna read this stuff here, obviously, and try to understand more how it works. I need to understand more as well how the Python interpreter works. Or this only captures when it fails. Now let's try this. Try a combination of these two. think I'm gonna have to put this function inside of the other one, so I can append there. Also, the other thing that I realized that I have to implement is some component that makes a thing load, like the loading thing, while the code executes and the API or server call is made, because it takes a while. It's a lot slower when you deploy because the servers are on different locations, so it takes a lot more time. And also, depending on the script, it's gonna take a lot of time as well. But I'll do this, I think, only after I have everything else. As list is working. But I'm not getting anything from this thing. Like, I need to study more how it works, these functions, so that I understand exactly what I'm getting. Because obviously it's different, like when you're executing, if you get the stack frame, you're getting something much different than if I'm just receiving like the description of what the person wrote. That wouldn't be very useful. And also the problem with the files as well, the file names. Pretty sure that the source code doesn't exist here. I think I've looked. Just the declaration, I think. Yeah. You should just test by passing valid code. See what's output's gonna give me. I think it's doing this because it didn't. It only updates when I reload the server, restart the server. I think it might be useful to leave this here, because the way that it's gonna work, I think, is if someone is importing something on the IDE there, and then it changes the file, then it's gonna show. But the challenge is gonna be, because I don't wanna show the names of the path from the absolute path on the repository, the server files. I just wanna show the files from the modules that's calling. So I'm gonna have to find a way to format. You always get the relative path instead. But I think you can just use libraries to do that, like the path library. Probably it's not that big of a deal. I think it's probably better to focus on the other stuff first. And then this thing here also I'm gonna have to figure out, because it's the same module, but it doesn't make sense. So what I can do is just get the same information that I was getting here to compare both of them. But I want to understand more first how it works. Because the main question I have now is if I'm getting the same thing that I would get if I was just executing code straight away, let's say. Directly there, because I'm using this function here, it might be like different, the information that I'm getting. So I want to understand more how they work. Like, what is the pipeline? If that's what I should ask. I'm gonna write this down. I think I have to create a file for this probably. Just to keep track of this information. Like, because yeah, essentially what I want to do is just get like this process of the compilation, and then from this process figure out what is the maximum amount of information that I can extract about everything while that is happening. And then the best way to organize that information in a way that with the network graph, putting colors and changing the size of edges and highlighting stuff during the execution, let's say, well, like, would make it so that it's a lot easier to understand what is going on instead of having to look for the source, looking the source code. Maybe we should ask before this. And that's the thing, is gonna show the information about the editor trace file as well, not only the function that they are running. To have to figure out like how to filter this, because the first frame is gonna show, maybe just put this way, just put a variable that skips the first iteration, create a global variable or no local variable. Then make an if statement that if it is the first frame, you skip. And also this is not helpful, module object that, the memory address. These are the local variables. And close this here. So obviously I can just filter the local variables based on the stuff that I have here on this script, so that it doesn't go on here. The line number as well. So those are the line numbers here. Like, I think it is working. I just have to figure out how to filter all the stuff that doesn't matter for the script. And also how to change the name of these functions, so I can get just the name and not the location of the thing in memory. But this is a local variable, so I guess I would just remove. So I have to create, I think I'm gonna create these functions outside of this one and to filter the objects. And here function. This module again. Like, that's an issue because like and I was thinking about this way before as well. That's like, because the idea that I had a long time ago is to be able to traverse the graph with the keyboard, and then as you traverse the graph it shows you the points on your computer, the files. But then obviously I need to create something that is going to be more complicated, more complex, because I have to use the sys system and see if I can get access to their computer. But then like I would have to do this from the front end, and then I would have to like store the information of where everything is, or figure out a way to get it from the, like maybe from the serverless function on Next.js. I think it's like impractical at this point and too complicated in the beginning at least. But I also think here you need to figure out a way. I either don't put the function name, the file name, or I have to figure out a way to get the relative path and see if that relative path is gonna be the same, because I think it's gonna be the same like if you're using any package, because the package itself is always the same. The only thing that changes is the absolute path from the person's computer. So I think that showing the relative path would be good enough, I think, because then the person can find on if they're using some module or something like that, they can just go through the relative path from the module. And maybe I can do some like something that explains on the page there like how to navigate, or I can link to a video that I made about the virtual environment and how to find the module. So what do I have to do? I have to filter these local variables. I'm also going to include, I think I'm going to leave local variables for now and then I'll worry about global variables. Trying to think if it is worth to spend some time now studying this stuff here to make sure that I think this one is safe already, but I remember that it wasn't working when I was trying to import things there because it was saying that it wasn't allowed for the functions or the modules. So I think I need to spend some time on this before I continue on this one. Because now at least I can see that it is pretty much the same thing that I'm gonna get. It's just like more steps to clean the data, I think, but the information is the same. I think the reason why I wasn't getting this before is because I wasn't compiling and I wasn't executing from the AST. I was just executing directly from the string, and then I was getting some different information. I wasn't being able to capture the stack frames, I think. Yeah, but now, like to test the file name things, I need to run something more complicated here that is going to import some module. So I'm going to have to fix the other thing first to import math and then do something with the library. But I also want to understand a little bit more before I do that on how these things work. I should gain more clarity in my mind of the whole steps of the system. And then formatting the data is easy, I think. It's not easy, but it's like simple. Because it's probably gonna have a list of objects, and then on the front end I just receive the list of objects, and then I change the function there, the data to graph function, to extract the information that I want, and then create the nodes and the edges based on that. And then I'm gonna start from the beginning with Pixie instead of doing with 3JS. I think the main things to focus now is one, security, to get all relevant information. You go, bro. Be right back. The timer went out and I didn't even notice. I think I'm gonna spend more time because I don't feel like taking a break. And then I think more half an hour and then I take the first break. There's also some interesting stuff that I can do with the abstract syntax tree, I think. Also, the other thing that I'm thinking about, which I think would be very good, and I haven't seen online, which is like very hard to figure out, which is like how exactly does the compilation of the language works. Like this whole process that I'm trying to clarify now. I think there isn't a lot of stuff out there that teaches people like exactly what is going on from the moment that the code is separating into those tokens and then creates this abstract syntax tree and then executes, like what's happening in the memory and what is going on like at the lowest level. What is the connection between the lowest level in the actual hardware of what's going on, like what registers are being used, how is the data being passed around, how is the difference between the data structures and the syntax that you write. So like I imagine the connection as being like a funnel, and it's kind of like a tree, I think, in the way that I'm picturing in my mind. So from the syntax you have this, which is the highest level of abstraction, you have this ocean in the bottom of information, and then the evolution of the programming languages is this encapsulating of concepts, which simplifies the geometrical structure at the layer that creates the informational field. So it's very similar to the way that the human mind works, I think, where I have a bunch of impulses coming through the universe. Then through the configuration of the electromagnetic field of your body, it becomes abstraction, which is a reduction of the complexity of the electromagnetic field, which operates under a certain frequency, and that becomes your perception. So I think is extremely interesting to me to make a graph, if it's possible. I'm not sure how difficult it would be, but to create a graph that shows what happens from the syntax to the lowest level. What is the chain of connection at each step of the code. And then be able to highlight the different stuff that is happening. And mainly capture patterns instead of thinking about the syntax, like how to understand what are the most common patterns that are being, because everything, the way that I picture in my mind is that everything is the same, like everything uses the same fundamental blocks. So the only differences between softwares, even in other programming languages, is that they use the same fundamental blocks to build more and more complex different structures that are all geometrical structures at different levels of observation. And it's gonna probably follow the Pareto distribution, where most of the stuff is gonna use the same patterns, and that's what software design is. So being able to highlight those patterns in graphs, I think is gonna make a lot easier to understand what's going on. So instead of thinking about how to code, because after some point it's not a problem anymore to understand what is going on, like because you know the language, you know that it's gonna use certain syntax. So the issue and the challenge of programming is being able to understand what is the best way to structure the fundamental blocks so that the informational field that it creates follows the Occam's razor, which is the path of least resistance, like the most optimal approach, which is the simplest one. So, and what are the differences? I think that's the biggest challenge that I have, and that people probably have, that I remember when I'm doing lead code problems, is that like it doesn't matter. The challenge is not to solve the problem. The challenge is to understand what is the best solution to the problem and why that's the best solution. So I think that's what I'm trying to capture, is how do you visualize that into a graph, and you extract the fundamental differences between different approaches and understand why some approach is better than the other. And I think it has to do with the geometrical structure of the software, obviously, because that's what creates the software in the first place. Just the way that everything, all the fundamental pieces are connected together to create something bigger. And that's what I want to be able to see on the visualization. So I think understanding more this abstract syntax tree is going to be very helpful, I think. And maybe looking into the other one as well. But I have to be careful to not be, because it might take a lot of time, like, and get lost in different directions. So I have to pick like one first, I think. So maybe the execution of the script is going to be the best one first. To like optimize everything. I think once I optimize the visualization and like close the whole feedback loop system and it's useful, then I can think about all of this other stuff. But the challenge that I always have is that I always have a bunch of different ideas before, and then like the mind races faster than your skills can build the thing. That's why it's hard. So yeah, be right back. I think this part that I'm doing now is probably the most annoying one, because I'm gonna have to test a bunch of different times with a bunch of different code to see like everything that is gonna be, everything that is possible to be an output there. I'm probably gonna miss a lot of things as well, to filter the stuff that doesn't matter for the visualization. This is kind of annoying. like it would be interesting to build something that allows you to see. I think that's what I'm trying to get at. Like from the syntax, what is the low level code that it produces, and then highlight the colors so you can see the connection of the instructions from the word that it uses and for the instructions in binary or assembly. So you have like a tree from the lowest level to the highest level of, and understand how like everything works on the lowest level. And then if you're able to do this for multiple different languages, then I think would be like really awesome. But it might be one of those things where it may be like very complex, a lot more nodes and not that useful in practice, but I think it would be interesting to see regardless of. This is also another thing that could be interesting to do, which is the connection between the abstract syntax tree and the stack frames. Like to show, highlight the connection between them, and then on the execution of the script, what happens from the AST to the stack frame. This sounds interesting. And the challenge here is that so many things to do. Like, it's very hard to think about. What should I do first? And there's so many things that I'm curious about to visualize. I think what I want to understand more first is like, because I already have a decent understanding of the stack frame, but I don't understand the abstract syntax tree very well. So I want to understand how the nodes are separated, because that way it becomes more like, it becomes easier to create connections between the two. Because I'm thinking that it might be better to display something else, but other than the execution of the script. Because the biggest issue with the execution of the script is that I'm gonna have to display a lot of nodes. So, like, I'm thinking that it might be better if I can find something else that I can display from the script that is still interesting in the beginning, because that way I can use like the libraries that are not very optimized to have a bunch of nodes. And then only after I work on understanding very well how to create the graphics and optimize the graphics so I can put a bunch of nodes, then I move more towards the execution of the script. This is the reason why I'm thinking about this now. And also because I think it will help me improve a lot in Python. And also understanding programming in general. To understand the connection of this abstract syntax tree and I just think it's very interesting. Be able to understand the abstract syntax tree and the stack frames, the connection between them, and then the connection between the abstract syntax tree and the tokens. Something that I wanted to do for a long time, I think. To understand like this whole chain of connections from the lowest level to the high level abstraction. What that looks like on when you visualize.
I believe that if we are honest with ourselves, that the most fascinating problem in the world is who am I? What do you mean? What do you feel when you say the word I myself? I don't think there can be any more fascinating preoccupation than that, because it's so mysterious, it's so elusive. Because what you are in your inmost being escapes your examination in rather the same way that you can't look directly into your own eyes without using a mirror. You can't bite your own teeth. You can't taste your own tongue. And you can't touch the tip of this finger with the tip of this finger. And that's why there's always an element of profound mystery in the problem of who we are. This problem has fascinated me for many years, and I've made many inquiries. What do you mean by the word I? And there is a certain consensus about this, a certain agreement, especially among people who live in Western civilization. Most of us feel I, ego, myself, my source of consciousness, to be a center of awareness and of a source of action that resides in the middle of a bag of skin. And so we have what I have called the conception of ourselves as a skin-encapsulated ego. Now, it's very funny how we use the word I. If we just refer to common speech, we are not accustomed to say, I am a body. We rather say, I have a body. don't say, I beat my heart, in the same way as we say, I walk, I think, I talk. We feel that our heart beats itself, and that has nothing very much to do with I. In other words, we don't regard I myself as identical with our whole physical organism. We regard it as something inside us. And most Western people locate their ego inside their heads. You are somewhere between your eyes and between your ears, and the rest of you dangles from that point of reference. But by and large, we locate ourselves behind the eyes and somewhere between the ears, as if within the dome of the skull there was some sort of arrangement such as there is at the SAC headquarters in Denver, where there are men in great rooms surrounded with radar screens and all sorts of things, and earphones on, watching all the movements of planes all over the world. So in the same way, we have really the idea of ourselves as a little man inside our heads who has earphones on, which bring messages from the ears, and who has a television set in front of him, which brings messages from the eyes, and all sorts of electrode things are all over his body, giving him signals from the hands and so on, and he has a panel in front of him with buttons and dials and things, and so he more or less controls the body, but he isn't the same as the body, because I am in charge of what are called the voluntary actions. And what are called involuntary actions of the body, they happen to me. I am pushed around by them, but to some extent also I can push my body around. This, I have concluded, is the ordinary, average conception of what is oneself.
wasting time. Everyone can bring their love. The stars and clouds above. Everything will be alive. In our hearts and souls and minds.
What I don't understand is if I can access these things here. Like, how does it work on this structure here? I get what is happening, but if I'm gonna access from the AST, how would I get each of these things? I think I'll study this a little bit more, and then after some time I'm gonna go back and figure out how to solve the issue that I was having, that I can import things here. Yeah, I was breaking the code when I imported libraries, even though they are part of the ones that are allowed here. So I want to understand how that works. 'Cause I remember the last time that I tried to import, I was getting some error here on one of these exceptions. I want to understand why that's happening. And once I have that, then I think I can... It's not that difficult to send the data now that I figure this out. Just have to... Yeah, maybe I should figure out how to clean up the stuff after. And then after that I send the data back to the front end, and then I create an algorithm that receives the data, puts on the graph, and then updates the context so that it loads the visualization. But I'm not that concerned about those parts, because I think that it's very straightforward with the stuff that I already have here. Just more like annoying things like formatting the strings, cleaning up the data. What I'm more trying to understand is how everything works, how the abstract syntax tree is created, what are the parts that is created, how the nodes work, how they are connected, what are the rules to translate the syntax tree into compiled code, and how to capture the connection between the abstract syntax tree and the stack frame. I think that's because I think that it's probably a better thing to display at first, but maybe not. Yeah, if I could make a graph that makes an edge between each node of the abstract syntax tree and the compiled code. But the problem is the compiled code is going to be a bunch of zeros and ones, I think. I'm not sure, maybe not, maybe... Or actually make a graph that connects the nodes of the abstract syntax tree with the stack frames. I think that would be interesting. Yeah, I'm gonna take a break now, and then remove the camera. I think while I take a break, I'm gonna watch some of these videos here. They talk about the abstract syntax tree as well. I'm gonna eat something while I watch. think I'm gonna spend, after I eat and watch the videos, I'm gonna spend some time trying to see if ChatGPT helps me to understand, to find what are the files that are responsible for this process of traversing the abstract syntax tree and compiling the code, so I understand more how it works. Yeah, I'll be right back.
So this session is called Master the Art of the AST. But before we explain what an AST or an abstract syntax tree is, let's talk about why it's an art form that we would want to master. So if you're using JavaScript today, you're obviously using a lot of tools. And maybe you've even heard about this expression called JavaScript fatigue, where you have to learn these tools. But I would argue that the real frustration comes once you've begun to rely on these tools and you find that they fail you. There is some breaking point. But we're going to see that more often than not, there's something you can do about it to solve this problem yourself. And we're going to demo that today by solving these three problems today together. So we're going to see how you can write your own linting rules to enforce your team's conventions, how you can write your own transpiling logic, and how you can write code mods or code modification scripts that will allow you to do a large-scale refactoring very quickly and with confidence. These are the three tools that solve these problems today in the JavaScript ecosystem. You have ESLint as a linter, Babel as a transpiler, and Facebook's JS Codeshift as a code mod runner. Now, other than the fact that these are open source tools on the web, which means of course you can go on GitHub and read their source code, what's unique about these three tools is that they were all developed with this idea of a plugin-based architecture. So that means that the original tool creators went to a lot of trouble to let you extend these tools and give them new capabilities without having to understand exactly all of the internals of how they work. Now, personally, the one that I got started with is ESLint. ESLint comes with about 250 built-in, very powerful, very well-tested rules, but I thought that the behavior that I was getting from one of them, I considered it to be a bug. So I did what you normally do when you encounter a bug. I went on GitHub, I opened up an issue, and I waited with patience for one of the maintainers at their earlier convenience to kind of give me a response. And so I was able to wait for about 10 minutes, and then I decided to go on their chat room and start hunting down one of the maintainers to give me an answer. And despite the fact that I was pretty pushy, they were very friendly. And what they explained to me is that this behavior that I'm describing, what I consider to be a bug, is not really a bug as they see it. But what's unique about ESLint and kind of what makes it different than previous JavaScript linters that came before is that they really encourage you to write your own rule. And it's meant to be extensible. And so they pointed me to the docs explaining exactly how to create your own rule. And I learned that in order to create an ESLint rule, I have to learn these two concepts. So ASTs, abstract syntax trees, and the visitor pattern. It wasn't very difficult, and after kind of learning the basis of it, I was able to write my own ESLint rule, which became a part of our build chain. And now whenever somebody violated this convention, the build would break, it would catch it early and fix it. Fast forward a few months later, I wanted to write my own Babel plugin. And to my surprise, I didn't have to learn any new concepts because Babel plugins also rely on ASTs and the visitor pattern. And as you can guess by now, the same thing happened when I wanted to write my own code mod as well. So that's why we only need 30 minutes left to this talk. We're going to be able to get all this done and learn the basis of extending these tools so they're no longer a black box and instead something that you can open up and tinker with. But ASTs are not unique to just these three tools. Pretty much any tool in the JavaScript ecosystem that you're using today that needs to read JavaScript or output JavaScript does so by manipulating and analyzing ASTs, so it's a worthy skill to have. A bit about me. My name is Jonathan Lebois. I'm a front-end tech lead at Sears Israel, where our mission is to reinvent the online and mobile shopping experience. Okay, so what are abstract syntax trees? Simply put, an abstract syntax tree is your original source code represented as a tree data structure. But let's see an example that will clarify this. So here I have pretty much the shortest piece of JavaScript code I can think of, and it's matching AST representation. Let's take a look at the code and the AST and kind of figure out why they match. So you have an assignment, var foo equals the string bar. And your AST always starts out as a root node called the program node, which has the body, which is just a list of all the statements in your code. Each statement will have its own node. In this case, we only have one statement, so variable declaration, which is composed of the kind, that's that left-hand part, var. And you have the variable declarator, which is the name of the variable, in this case, the identifier foo, and the value of the assignment, which in this case, since it's a hard-coded string, anything that's hard-coded, the name of the node that relates to it is called a literal node. So this should make it a bit clearer, but let's see if we can even improve on this and make it clearer. So this is the exact same AST, but represented as a JSON object, and as developers, I'm sure this is a lot more nice to look at. One thing to notice about the JSON representation is that each of the nodes always has this type property. So there's a set list of available types that you can have in a valid AST that describes valid JavaScript. And you kind of have to learn the properties of each one, but you never have to really memorize it, and we're going to see why not in a minute. But do notice that if you know the type of the property, sorry, the type of the node that you're on, then you can know which other properties it's going to have, and then you can understand how to read that node. There are 4 steps we have when we're working with ASTs, and we're going to go over each one. Well, actually, if you're only writing a tool that needs to just read JavaScript and it doesn't have to output JavaScript, you can only get away with just using the first 2. So the parse step. The parse step is all about taking your original source code and converting it into an AST. There are several open source parsers online, and what they all share is that they expose a parse function that takes a string, which is your original source code, and returns a JavaScript object, which is the AST. Now, for the examples that we're going to take a look at today, you don't have to choose a parser because all the tools that I mentioned already chose one as default, which just works, but you can actually in most cases swap it out for a different parser if you think you need to do it. This is a great resource. If you only remember one resource from this talk, make it this one to get started with the AST tinkering. It's called astexplorer.net. And it's a similar tool to kind of a JSBin or a code pen that lets you play with code online. And what you can do is you can just type JavaScript on the left, and it'll show you the matching AST on the right, and it's interactive. So if I have a lot of code here, I can click on the line on the left-hand side, it'll take me to the matching node on the right-hand side, and I can also hover over nodes here, and it'll highlight the relevant part in the code in the left-hand part. So this is why you never have to memorize the set list of available types, because you can always just paste in some code here similar to the problem that you're trying to solve, and be familiarized again with what the type of node is called and what properties does it have. So this is just a parser online ready for you to play with. Now let's talk about the traverse step. Why do we need to traverse our AST? If we're reading JavaScript, we're trying to analyze something about that JavaScript, and we only care about some elements or some attributes of our code, not all of them. That means that we first need to find the nodes that we care about to solve whatever problem it is we're trying to solve. So let's talk about the traverse step in the context of the first problem that we're going to solve today together, and that's writing your own ESLint rule. Let's see the example that I told you about earlier, the one that I got started with. So first the problem, and then the rule that solves this problem. We're going to be talking about something called code piggybacking, and don't worry if you haven't heard of it, because I just made it up recently. So this is piggybacking, if you're not familiar with it. It's when you stand on somebody's shoulders. You don't have to have an actual pig involved, but let's see what piggybacking looks like in code. So here I have ESLint hooked up to my editor, so I get this nice integration here, and it's showing me that something is wrong. This is one of the built-in ESLint rules that catches any variable that's not defined. So there was no var statement saying that there's a variable called acme. It's not a function parameter. It wasn't imported via an import statement. It's just something that's assumed to be globally available, even though it's not. It's clearly something that we just made up. So this works as expected. But what surprised me is watch what happens when I do this. I changed acme to be a property of the window object. And because window is whitelisted, because ESLint knows that I'm writing browser code, so console is whitelisted and window is whitelisted, it doesn't check anything beyond that point. But if you're writing browser code, you know that anything that's a global variable is also a property of window. So in terms of runtime implications of this, it's exactly the same. And yet ESLint ignores this completely when acme starts to piggyback on window. So that's the problem that we're trying to solve, because without this, people will be able to commit code like this, and in runtime, this variable might be undefined, and etc. So let's see how the rule that solves this works. This applies to this rule, but also to any ESLint rule. The structure is the same. So an ESLint rule is a node script where I have to return an object. The properties of the object, their name has to match one of the known AST valid types. And the function that we pass in as the value will be called for each node of that type as we traverse our tree. But let's figure out what we need to input here for our own rule. So we care about cases where it's window.something, where that something is not a valid global. But if we zoom out a bit, we need to find all nodes that are just of the type something.something, right? foo.bar, a.b. So we go on AST Explorer, and we paste something like that. And we wait till both are highlighted, and we can see that the name of the type is called a member expression. And a member expression will always have an object property, which is that left-hand part, and you can see it's highlighting it. And the right-hand part is referred to as the property. So this is why in our rule that solves this problem, we're going to write member expression here. Now, this function will be called for any member expression in our code, but we don't care about all member expressions. We just care about the ones where the object is window, and the property, the right-hand part, is something that's not a valid global property. We're going to see how that helper function is implemented in a minute. But assuming that this condition is correct, then I already found the piece of code that essentially means that somebody is piggybacking on top of window, and this is something that I want to report to catch early. So ESLint exposes this context.report method, and I can pass in whatever error message that I want. And this is how this helper function is implemented. ESLint also analyzes scope on your behalf. So it exposes this variables array and already pre-populates it with anything that's in scope in the environment you're running under. So when you, as a user, configure ESLint, you tell it, are you writing browser code, are you writing a node? And it'll pre-populate that with the known globals in that environment. So for a browser, this would be document and window and console, etc. And as it would iterate through this node, it would see that in our particular case, there is no acme variable, and that's why it will tell us that this is in fact an invalid global. So let's see this in action. This is, again, ESLint integrated with the editor, and my silly little piggybacking error message gets the seal of approval because it looks very nice when you get the integration with ESLint like that. Yeah, so ESLint rules, custom rules, you can support anything that one of the built-in ESLint rules does. Now, without knowing, we use something called the visitor pattern here. Just the fact that I didn't have to tell ESLint how to traverse a value tree, how to go from the root node all the way to the bottom node. I only had to tell it which kind of nodes I care about and give that callback function to be called for each node of that type. That's making use of the visitor pattern, and that's going to come in handy in the next example as well. Now let's talk about a tool that needs to output JavaScript as well, and it does so by manipulating the AST of the original JavaScript file. The most well-known tool that does this is Babel. Babel started out as a project called 6-5, and its main objective was to let you write ES6 and compile it down to ES5, which can run on any browser. But they realized that the problem that they solved is more generic, so they rebranded it as Babel, and they went into a lot of trouble so that it's now based on this plugin-based architecture, and you can extend it by writing different plugins. The example that I'm going to show now is one of the built-in Babel plugins. I chose it just because it's very simple, but helps to get the message across. But a third-party plugin would also behave the same way. So first, the problem that we're trying to solve. You might be familiar with the debugger statement in JavaScript. If not, it's just a keyword that lets you trigger a breakpoint immediately from code. And it's great for development, but it's not something that you would want to ship to production, because under some circumstances, it could actually be triggered for your users, and then your entire app would freeze. So as part of preparing our code for production, as part of us using Babel, we can choose to just get rid of it completely. So if I run Babel, it will produce the distribution version of this file, and it will be the exact same code, only the debugger statement is gone. Now let's see how it's implemented. So this should look familiar to the ESLint example. A Babel plugin is just a node script where we return an object, and here it's even wrapped inside this visitor object, which reminds us that we're using the visitor pattern, but the same rule applies. So we need to figure out what's the name of the type of node that we care about, which again we can use AST Explorer for. So if I just type debugger, I see that since debugger is a reserved keyword, it also has a reserved node AST type all on its own, which is called debugger statement. And for any debugger statement in my code, I can call path.remove, which is essentially modifying and manipulating the AST and removing that node from the code. Of course, you can apply some custom logic here, do some other conditional checks. But for our example, if we find the debugger statement, we just want to get rid of it completely regardless. Now let's talk about the generating code step. The generating code step is kind of the reverse of the parse step, right? The parse step was all about converting our code from just a source string into an AST. Now we have our modified AST, and we want to regenerate it back into code. Now, you implicitly have to make some choices when you're generating code from an AST. Are you using tabs or are you using spaces? Windows line endings or Linux line endings? When we are using something like Babel, we don't really care about which one we're going to use, because Babel code is typically just throwaway code, right? You regenerate it every time that you push to production, and during development, maybe even every time you hit save. But now we're going to see a case where we're going to need to be a bit smarter with the mechanism we use when we generate code. That's the case with JS CodeShift. JS CodeShift is a framework by Facebook, which tries to solve the problems of doing very large-scale, very tedious refactoring, where doing so manually would be very time-consuming and potentially error-prone. So what it lets you do is it lets you write something called a code modification script, that describes how you want to change your original source code, and it will iterate through your files and change it accordingly. So essentially it means that you're going to let machines write code for you. Is there anyone here who already dismissed this because he thinks this is a terrible idea and it would be super buggy and never let machines write code for you? So this was my initial reaction at first. So what I would say to that is that you should be skeptical. You should definitely understand the implications of letting a machine write code for you. You should test it very well, and you should understand all kinds of edge cases that you might have missed initially. It's not something you just run, push to production, go home. So skepticism in this case is healthy, but this has merit. It's all a trade-off of, is it more time-consuming to test the code mod very thoroughly, opposed to doing the refactoring manually? So what are the type of things we can use JS CodeShift for? Well, kind of the most well-known thing that people are using this for is for doing something that's kind of the reverse of what we use Babel for. When we're using Babel, we typically do it to convert from the newer JavaScript syntax down to older syntax that can run on any browser. But what if we have a large code base that was written long before the days of ES6, ES7, ES8, and we want to start adopting these latest best practices? For example, what if we want to get rid of all our boring old var statements and turn them into shiny new let statements? Let's see one option of how you can try to tackle this with a code mod. So in this code mod, what we do, again, a node script, here we need to actually explicitly parse our code, but JS CodeShift does it. So J is just a wrapper around the JS CodeShift API. We pass in file.source, and we get root, which is the root node of our AST, which contains the entire AST. We're doing something similar to the visitor pattern, but no longer with this object syntax. So here we just call root.find, and we tell it which kind of node we want to find. Because we're trying to do something on all variable declarations defined with var, we pass in variable declaration kind var. Again, variable declaration, you can find that out on AST Explorer. Then we pass in the function that will be called for each node of that type. And inside, what we want to do is create a new variable declaration, pretty similar to the previous one, that's that p parameter, but different in a way that now it's defined as a let statement. Now this is just an object in memory, so the next thing we do to actually change the AST is we swap them out with the replace with method. And the last thing we do is we call root to source. Now, remember we're talking about, in the context of the generate code step, what JS CodeShift does when it regenerates our AST into code is it tries to understand everything about the original code style that we were using. So are you using spaces or are you using tabs? And we'll try to change as little as possible about the source file, because it's not writing a new file, it's actually overwriting your original file. What this means is that when we go into our git source control, whatever diff window, before we commit this, we're going to be able to see exactly what changed, and it will make it a lot easier to pick up on potential bugs introduced in this code. Speaking of bugs introduced by this code mod, does anybody have a problem with this code? I'm not sure if there are no hands up, I'm not seeing them. But you might have noticed that what I did here is I actually turned any let statement, any var statement into a let statement. Now, var and let aren't interchangeable. There's a reason that we have this new let keyword, right? It means something different. Var declarations are function scoped, and let declarations are block scoped. So that means that we can't just change it like that. We have to check how the variable is used, because if before we were to define the variable with var inside a scope and use it outside of the scope, it might have been like smelly, frowned upon, but it would still work. And now it would actually be a syntax error, because let enforces it so that you can't use the variable outside of the scope where it was defined. The good news is that there is a better code mod that solves this, a bit longer, more lines of code. It's open source on the web, created by Christoph Nakazawa, and it's called the no vars code mod. And it does this switch intelligently, so it checks how the variable is used, and it will even promote it all the way up from var to const if it can. Let's try to see it in action. So here I'm just calling the JS CodeShift command line tool, and I'm telling it to use the no vars transformation on this repo. What it will do, it will spawn different child processes, just so that if your code base is indeed very large, it will do so very quickly. And oops, sorry. And if I go in and see the changes, I can see that all my original var statements, most of them are now const statements. But in some cases, like here, we can see that one of these variables, I guess, was being reassigned to, so it was only able to promote it all the way up to a let statement. This repo isn't one of mine, actually. What I did is I went on the global issue search on GitHub, and I looked for people who maybe aren't familiar with the fact that you can do this type of refactoring very easily with code mods. And I looked for any open issues that want to replace var with let, and I found this one. This person wrote, it's 2017, use let instead of var, or at least that's kind of the tone that I'm imagining in my head when I'm reading this. And what I love about this also is that this was open in 2016. So now we'll pray to the Wi-Fi gods and try to commit this. And we can open up a pull request. So it's really that easy. Now, I trust this code mod because I've used it before and I trust the person who wrote it and it's well tested. But yeah, it's not something that you would definitely do as quickly like that. But once you have confidence in your code mod, it can be that easy. Thank you very much. This repo up here on the top contains a bunch of links related to getting started with the ASTs. So if you want to get started, this will be something that I would recommend. And also, feel free to reach out to me on Twitter. I have open DMs. You can ask me, tell me if you're getting stuck. I'll be more than happy to help you out as well as here at the conference. Thank you very much. So this
Well, thank you very much for the wonderful introduction. As I said, I'm Chase Stevens. I do want to take a moment before I really stop my talk in earnest, rather, to just acknowledge what an honor and a privilege it is to be here, getting to listen to a speaker such as myself, a real master of the craft. So you should all feel very lucky. I do want to just make a small shout out to my company, Take a Metrics. It's a Boston-based company. We build a machine learning platform that helps online sellers optimize for profitability across their entire business. We use really interesting tools, so TensorFlow, Jupyter Notebooks, Hypothesis for testing. It's a really cool place to work. We have currently, I think, $3 billion of retail revenue that we manage per year, and that's across thousands of sellers that include some of like the hottest brands. So absolutely, if you are looking for a new place to work and looking for a place where you can have a real challenge, but also get to work with cool people, then drop me a line. All right, I also want to say that this entire talk is up on GitHub, so if you like after the talk, you can go and check out this out. There's a Docker image you can build that will allow you to run this, so hopefully you'll find that very useful. Right, so the premise of the talk here basically is that, first of all, I'm not going to be showing you, I promise, anything more complex or difficult than parsing JSON or manipulating the DOM tree or generating XML, right? It's really basic stuff. People get very flustered about ASTs, I find, but it's simple. I'm going to show you a lot of tools that are out there already on PyPy, installable, that will allow you to leverage the AST to do static manipulation and runtime manipulation of code, which is obviously very cool. And also, hopefully going to be not giving you enough information that you can just stand up and start hacking on AST stuff, but enough to get started, like places to look for, resources to go to. And really all I'm asking in return is to be revered as a modern day Prometheus. Just someone who's coming down from Olympus and bringing the knowledge to all your ignorances about what the AST can do. So it's a very simple quid pro quo. I hope we can all agree to this. So let's start off with an AST. The AST stands for abstract syntax tree, but that can be a little bit of a misnomer, I find. Really what you want to think about conceptually here is this is a way of representing in Python code, right? A way of programmatically viewing, inspecting, and manipulating your source. So for instance, really simple, right? X equals 1 plus 2. We can take this and use the built-in AST module in Python, parse this source code as a string, and what we get back is a tree, basically, that encapsulates all of what's going on there. And you can see here that we've been returned a module object. Not obvious at first what that is. The reason why it's a module object is because the central conceit behind the AST module is that you're maybe parsing like source code files, entire files rather, that you're going to then end up using. But we can do other things to inspect this, right? So there's a built-in dump function that will allow us to see what that tree looks like. And you can see here beyond the module, there's a body that has the assignment that we've just made. We're assigning to this variable x. The value of the assignment is a binary operation where the left-hand side is number 1, the right-hand side is number 2, and the operation performing is addition. So hopefully pretty intelligible. A little difficult to read maybe, so there's this awesome tool called ASOR. Primarily, its use is in round-tripping ASTs, right? So allowing you to go from source code to the AST representation, then back to source code. But here I'm using it just to get a slightly terser printout of what the AST is, something that's a little more readable. And beyond that, there's also a tool called Show AST for Jupyter Notebooks. They'll show you a visualization, right? Something graphical that is the same thing as the previous two cells, but just a little easier to inspect sometimes if you want to see what's going on. Now, why did I say that AST as abstract syntax tree is a little bit of a misnomer, possibly? I think when people hear the word abstract in this, they tend to think, ooh, there's like monads probably, or like oblique references to Platonic ideal or something like that. I don't want to do that. I don't want to worry about that. It's not like abstract, like super conceptual. It's abstract syntax. So what I mean by that is, again, very simple expression, 1 plus 2 plus 3. You can see in the AST it's being represented as 1 plus 2 plus 3. But you'll note the second cell here, we have some brackets around the 1 plus 2, and that isn't represented in the AST. So what's being extracted away is the syntax, right? We're not able to go from the AST to get back to the precise original source code because those brackets have been basically stripped from this. And likewise with, there's no representation like a colon, for instance, in the AST, or white space per se, right? You can't tell how many tabs or spaces I used to indent something. It's more genericized, I guess, version of the syntax of the source code. You'll also notice that as I go along here that what the AST doesn't contain is any sort of runtime information, which includes types. It doesn't include type annotations, which are part of the syntax, right? But not types themselves. Why do you care about the AST just in general, right? Why would you want to look at this? Well, here's a good example of why knowing the AST or looking at the AST for different pieces of source code is super useful, right? This is list comprehension here, right? Item for group, for item group, if checked group. This is how I thought list comprehensions had to be written obligatorily, right? You had, here's what I'm going to return, here are all my fors, here are all my if conditions. But if you look at the AST, you'll notice it's a list comprehension, right? What we're returning is this item expression, and we have a list of generators. These are comprehensions, and each of these comprehensions has a list of ifs. So what this means is actually I can do this instead, right? I can have the if directly follow a for, and this is something I didn't know before I looked at what is the representation in the AST of this list comprehension. And what this does is means that I'm only running that check call for every group and not for every group and every item in the group, right? So you get a little bit more efficiency. You can also have multiple if statements, so you don't have to join them together with and, which can get a little messy syntactically. So there are things you can learn about how Python works just by looking at how the representation of the syntax is. But this is the real piece of response, right? This is where I'm going to take some source code, have it parsed as this parse variable, and then use the built-in function compile. And what I get back is this code object. What is the code object? Basically, we've taken that source and interpreted it, and now we have some bytecode, right? So this is not like the AST model is not just something that someone put into Python on a lark. This is deeply embedded into the system, right? This is very, very powerful because what we can do with that code object is we can then create an environment, execute the code within that environment, and then pull things out of the environment, right? So like I said, here we have this code that's basically assigning 1 to x and 2 to y, and we can pull out from the environment I passed in x and y. And of course, if I wanted to, I could have begun by putting things into that environment for that code to access. So again, super, super integrated. One question you might have at this point is, well, if I'm running a program, I want to have access to some of the functions I'm running. How would I do that? One method is to use the inspect module. So inspect has a get source method defined that will give you back the source for a lot of Python objects, not all of them, right? So functions and classes definitely. If you want to access like lambda expressions, or if you want to access like generators, it's a little bit more difficult. You have to use what's called a decompiler, which basically will take the bytecode, inspect it, and sort of reverse engineer an AST out of that. But for most applications, inspect get source is what you want, right? And again, now that I have the source of the function I've just declared above, I can take that, parse out the AST, do whatever I want to it, and recompile it back to the functions I want to. Right, so there are obvious applications for this in static analysis. Just to be clear, what is static analysis? Well, consider the counterexample of a profiler. So a profiler, you have to be executing the code intrinsically to be profiling it, right? You want to see what runs quickly, what runs slowly, what's calling what, and that is something you can only do if you actually execute the code. Static analysis is when you're doing analysis without executing any code, right? So very trivial example would be like counting the lines of code you have. Another example that sort of highlights the distinction here is if you had a program that was checking the syntax of all the code in your code base, right? In that case, you are parsing the code, right? You're going to be into abstract syntax trees, but you're not executing it, right? You have the difference between the representation of the code and the actual running code itself. So how might we use the AST module to accomplish this? Well, here's a really simple program, I guess. But basically, I'm assigned to these 3 variables, A, B, and C, right? And if we read this file and we load it in as an AST, you can see here I have my 3 assignment nodes. Shouldn't be anything surprising. But built into Python, we have this AST.nodeVisitor class that I can subclass. And basically, what this allows you to do is to override methods that all take the format like visit_node_name. And when I instantiate this new class and then call .visit on some AST, it's basically going to traverse that tree. And then every time it reaches an assigned node, in this case, going to call the code that I've given. So in this case, what I'm doing is I'm looking at every target of the assignment, because assignments have multiple targets, right? You can have x equals y equals 1 or something like that. Checking to see whether it's a name node, as opposed to say assigning to an element of a list or a key in dictionary, something like that. And if so, then just printing that out. And you can see here when I run this, it prints out ABC. Already, there are like serious legitimate applications for even something this simple, right? Like if anyone's familiar with Alembic, it's a migration system for databases, but basically it requires you to declare at module level, I believe, this is what this revision's hash or number is, and this is the previous revision that's based off of, right? So you can take something like this, go through all of your migrations, and then create like a graph to ensure that there are no cycles in them or something like that, right? They're already, even with this like very minimal built-in functionality, a lot of things you can do that are interesting. But further to that, you can do even more cool stuff, right? So this is a tool called AST Search. And if at this point in the talk you're thinking, boy, I wish I hadn't come here, then this is a tool for you. Because basically, AST Search is using the robustness and power of the AST, but abstracting away for you all the sort of internal complexity of having to learn about ASTs, right? So you can see here, I'm using this as a command line tool. I'm basically doing AST Search and saying question mark equals 1. So that's to say some wildcard equals 1, and searching for that sort of pattern in this protobuf repo, right? And when I get back, you can see I have some things where we're assigned to an attribute of an object. I have some things where I'm assigned to a name, right? In the AST and the internal representation, those two things are very different. But AST Search allows you to not have to worry about that and just do the sort of very simple pattern matching, which is great. However, obviously there are a lot more things you can exploit with the AST. So another tool out there is called AST Path. And this is a little more complex. You have to know, what you're doing in terms of what the AST looks like, you're going to match on. But basically what this is doing is allow you to supply an XPath expression. And by doing that, you can capture really interesting properties of your code and search them through your code base, right? So this is something you can't do with like a regular expression. For instance, I'm looking for numbers where the number's value is greater than 100, right? And because the AST is going to handle integers, it's going to handle floats, doesn't care whether there are underscores in the numbers, doesn't care whether you're using scientific notation or not. It's all handled for you. And I want to find those only if they're not assigned to something, right? This is a sort of deeper structural property of the code that is difficult to capture if you don't have access to the AST, but with the access to the AST, it's almost trivial to capture, right? And you can even do things like not just capturing one line, but here I'm searching for all function definitions that have at least one decorator and have a for loop in the body, right? So I can capture really, really deep structural properties of my code that are very, very difficult, if not possible to capture in any other way. So PEP572, rest in peace, Guido. People are aware of this. Basically, what it allows you to do is, opposed to saying match equals pattern.search data and then use match in this if statement later on, you can use this assignment expression syntax to basically assign to match within your if statement. There are a bunch of other use cases, but this is sort of the primary one that's touted. Obviously, I don't have a very strong opinion on this, mostly because I have a strong interest later on not being thrown to the back of a car. But if you want to see, well, where can I apply this in my code base, you can use AST Path. You can say, all right, I want to find all assignments where the name is the same as the very following statements, if it's an if statement, being used in the test for that if statement, right? So a few of these lines, because it's not respecting white space or anything like that, a few of them, the second line is blank. But you can see here, for instance, here we have this callable being assigned to, and then if callable is none, that's a candidate for replacement with the new assignment expressions. Now, I know some of you are thinking, ooh, I'm going to go back. I'm going to use that AST Path tool, and I'm going to start creating this sort of programmatic way of capturing things that I don't like in my code base. Sort of things where you have PR after PR after PR of just commenting the same thing over and over and over again, and you just want to have some sort of tool you can run that catches all of those things that you don't like. Don't worry, fam, I got you covered. Let's say that this is my code base, pretty small. The function that I'm interested in here is this call to deprecated function. I have just written in my PR a super sexy new function that's going to replace this, but it turns out there's like 3,000 uses of the deprecated function. I don't really want to do that all my PR, and some of them are a little difficult to undo, and like, let's just leave that for someone else, right? So I can use this tool called Bellybutton, right? And this is basically a wrapper around AST Path, but I can define different rules. So in this case, a deprecated function call rule. I give it a description that's going to be basically the error message if this is caught in my code base. I give it the expression, which is basically this XPath expression that I want to run against the ASTs of all the modules in my code base, and I can give an example of what this looks like, what not to do, and something to do instead, both of which are validated against that expression. So when you run this tool, you can be sure that the example encounter example you've given actually adhere to what you're looking for. And then also some stuff about like where do do I want to run this, which is not super important. But basically, I can then take this and run this on my code base, and as you can see here, it gives me back, oh, this linting has failed because I'm using this deprecated function in this particular code.py. And obviously, this is sort of just the tip of the iceberg, right? This is a pretty superficial thing to look for, but you could also do things like, let's say I have an enum with a bunch of different values, and I want to make sure that if I'm sort of working with one of those values, that all the other cases are handled, right? I could write an expression that says, if I have an if statement where I'm checking against one of the values, then I am obliged to also have else ifs for every one of the other values. This is something you can implement relatively easily with an ASP path expression. And then all of a sudden, you're getting some of those really cool compile time almost guarantees that super functional languages like Haskell and Scala will give you, but specific to your project in Python. Just a little brief interlude. So these are some of the tools I've talked about so far. Two that I didn't mention, but which are very cool. You should look at them. One is called Green Tree Snakes. So basically, this is like pitched as the missing guide to the Python AST, but it is a riveting read, and I highly recommend it. The other one is Python AST Explorer. Basically, what this tool lets you do is it's an online tool. You paste in some code on the left-hand side of this page, and on the right-hand side, gives you like this collapsible view of a tree that basically the code will be represented as in the AST. Again, super useful, especially if you're going to go and write like AST path expressions, for instance. The thing is, because this is on GitHub, you can just go take a look through these. Maybe give them a few stars. I don't know. I know that it's a little bit of a vanity metric, but do consider that in our post-apocalyptic, post-singularity future, aka Q1 2019, Git stars will be used to determine whether or not you have to work in the silicon mines. So give generously. Right, so now we're going to be shifting a little bit. Before we're just looking at what's the structure here, can we query on the structure? Now we're going to be looking at, can we take the underlying AST, do some manipulation on it, make some changes to it, and then run that code. So this is where a lot of people get very uncomfortable, and there's a good reason why. So there are basically two forms of AST manipulation. I'll call them static and dynamic. Static AST manipulation is basically, so you have some code base, right? You have a program that's going to run on that code base, and that program reads each of the files, does some manipulation to it, and then writes it back out to source, right? What's the problem with this? Well, from a development standpoint, it's a little weird, right? Because if I have this like pre-process and then post-process code, am I meant to be working with the post-process code? Is that I'm checking my version control? If not, then I guess I have to build that during like my build and deploy process. But then how do I find out what the code ended up looking like at the end? Like it's a mess. Dynamic AST manipulation is no less of a mess. But basically the premise here is that as opposed to doing that once in sort of this processing process, you're going to be doing it with code you have access to in whatever scope you're in, right? So sort of live code objects that you're going to be manipulating, which obviously has a similar problem in that how do you know what you got out? And like if there's an exception that ends up being raised and you look at the traceback, you're going to be pointing to a line that doesn't match up to anything in your code base. So again, a little bit difficult to debug. So with that being said, how many people's initial reaction is, oh man, get that as far away from my code base as possible? Can I get a show of hands? All right, few. Now, how many people use PyTest? I think I see some people raise their hand twice. Well, let me tell you something. PyTest, what a great tool, right? So simple. I just wrote this little test. It's like super easy. I don't have to like create a class and use self.assert not is false or whatever in unit test. And hey, when I run it, look at this error message I get, right? It says, hey, this failed, but not only did it fail, like I tried rerunning it, there's some weird stateful stuff going on, and like you should really look into this. Or maybe I had a different test, right? Maybe I had a test where at the end of it I was like saying, oh, assert this dictionary equals this dictionary. Oh, and look, PyTest gives me back this like super nice diff of saying, oh, these keys don't match these keys, and it's just so easy to use. How does it do it? Well, it takes the code that I have there in cell 32 and transforms into that monstrosity, which no one wants to write or read. And this is not meant to be like a bait and switch. Like this is a really good application for AST manipulation. The sort of tooling that you are going to run as a developer locally is a fantastic candidate, right? Because you may want to do manipulations like this that make your life a whole lot easier, but you wouldn't necessarily be comfortable doing in like a super critical production system. How many people here are familiar with protobuf? It's not super critical, you are, but a lot of hands, that's great. So essentially what it is a schema language for serializing messages, right? So very simple schema I have here. I have like a latitude, a longitude, and a message, and this is like something I want to log out to some system, right? What's the problem with protobuf? Well, it's super strongly typed, and Python is pretty dynamic. So let's say this is my function that I'm going to write to create this protobuf message. I have my lat, I have my long, I create the message, I'm starting to populate these attributes. Maybe I have to do some conversions or something. Maybe I want to format the message. And then I want to return the protobuf file. Looks good, but what happens when I put in a float instead of int? Protobuf goes berserk and you try to assign to that particular attribute. And this is the problem, right? Because the last thing you want is for your logging system that's meant to log your errors, also creating errors that then don't get logged. That's a poor outcome. So the other, this is not just, this is sort of a trivial example because you say, oh, well, you could use MyPy, you could just make sure everything's an int, yada, yada, but how do you know your int is within the int32 range? It's a little more difficult, a little more onerous. What you really want that function to look like, the function that constructs the protobuf message, is more like this second cell, right? Where you're creating it, and then you don't want, like, if there's something going wrong in the conversion, you don't want that to be caught, so you want to assign that to like this temporary variable, and then, you want to assign to the attribute, and you want to catch type error, I guess, maybe you want like a warning or something, then you have to do that for every one of these, and then you return it, and it's like, oh man, this is like not clear to me as some other developer who has to go into this code and figure out what's going on. So how might we solve this? Well, the AST module also has a built-in node transformer class, which is a subclass very similar to the node visitor class, and this is a pretty long bit of code here, but just to make it clear, basically here I'm checking, are we assigning to an attribute of this protobuf message? Here is what I'm going to be replacing that assignment with, right? So I'm saying basically the same thing I just had in the previous slide. I have to assign to a temporary variable, and then I have this try except, which is going to take that temporary variable and assign it to the protobuf attribute. And then finally here, this is the only part that's a little strange. Basically the visit assign method is expected to return a single node, but we want to replace the previous single assign node we had with multiple nodes, so we wrap them all in a if statement that always is going to run. And what do we get out of this? Well, if here's our original function, we can do the same stuff I've shown you already, right? Get the source of it, parse that into an AST, and then call the assign replacer.visit method on this, then transform that back into our source code. Of course, we also compile it if we want to in some environment, and we get back essentially what we wanted. And I think it's an open question whether this is more or less maintainable than just writing the code that's output, right? Because the code that's output is really oblique and opaque and not a great experience, whereas the other one is pretty terse. One thing you should know is that, is this testable? Yeah, totally. As testable as any decorator, right? You can in fact wrap this up in a decorator. You don't have to have this at the bottom of your module or something. It's just another thing where you need to pass in a bunch of functions, make sure that the functions you get back from it are performing what you expect them to. It's something you can use in code. The other thing about that previous AST transform that I showed you is quite verbose. You might say, well, you have to know a lot about the AST to figure out what's going on there, or to write it, in fact. Here's another tool called AST Tools, a fantastic library. You can use this quoted template decorator, and basically this gives you a function where I can pass in the protobuf attribute I'm going to assign to as an AST node, and the value I'm going to assign to as an AST node, and specify what I want to get back. And when I run this, I'll get basically an AST, a list of AST nodes that'll have this assignment, this try except, yada, yada, yada. So it makes it a lot cleaner, a lot easier to follow. DSLs. Everyone loves a good DSL, right? We are infatuated with them in programming. We love SQL, we love regular expressions. What's the problem with DSLs? We represent them as strings in our code. What does that mean? Well, supposing, for instance, that this is the space of all strings, the space of all regular expressions might look like this, right? There's just so many strings that aren't valid regular expressions. What's the practical impact of that? The practical impact is you're not actually leveraging this tool you have, the Python syntax checker, basically, to make sure these are valid. So you have no guarantees about whether your regular expression when it's run is going to compile or not, right? Another example, strings, right? XPath, strings, boom, 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 SQL, boop. Not a great situation, right? There's a little bit of a mismatch here. And what's the practical effect of this? I'll tell you what the practical effect of this is. The practical effect is that Sam, who sits next to you, just check this into the code base, and some brain is never going to run until you go on holiday, and that's exclusively going to run, and you find out the Postgres actually doesn't understand Shakespearean English. But on a serious note, I once had a project I was working on where it had a lot of XPath expressions, and I ran a little tool on them that I made to see what was going on, and about 20% of them were invalid syntactically. So this is not just like made up, like academic problem. This is something that real people have wet themselves to sleep over. So this is a serious issue. But here's a solution. What a fantastic use of AST manipulation. A little tool called Pony ORM. What this does is it lets you use generator syntax to create SQL queries. How to do that? Well, you have this very simple expression, customer for customer and customers. If some customer or the total price is greater than or equal to, or sorry, greater than 1,000. What does it? It takes that generator, it decompiles it to get the bytecode, to get the AST, then does the manipulation from the AST into SQL, basically. And what's the nice thing about this? Well, okay, maybe it doesn't give you the full expressive capacity of SQL, but what it does give you is a guarantee that Python, when you import this module or whatever, is going to throw up and say, oh, syntax error, and you're going to know that from the start, right? If you have syntactically valid generator expressions, you know that you can get the syntactically valid SQL. It's a guarantee. And likewise, you can make sure that if you want to later on, you have a programmatic way of manipulating this using the AST module, as opposed to having to do like weird string manipulation. There's also a tool called XPython that will do this for XPath expressions. I don't know if one for regular expressions, but I'm sure one is forthcoming. Testing, right? This is a kind of a broad topic, but you ever notice in testing, like, all right, I wrote my cool, like, quick sort implementation. I don't know why I wrote it, but I got a check mark on my PR, so that's all cool. I'm using modern CI practices, so of course I had some tests in there, and I made sure those tests passed, and everything's copacetic, and I'm about to merge into master. Since my tests all pass before I merge into master, why do I have the tests still? I mean, obviously, maybe when I was writing this, I wanted to have them to make sure that my code ran properly, but now I know it runs properly. Why don't I just delete those? Well, it's not really that you care about whether your code you have runs properly, right? It's actually more that you want to capture if someone else comes along and manipulates this and makes some changes that this still works, right? So it's not that you care about whether your code now works. You care about whether if your code were wrong, that this test would fail, right? That's how you know whether it's a good test or not. If the test would fail, if your code were wrong. Is that hard to capture? No, because we can use the AST, right? We can use this cool tool called Cosmic Ray. We can have it automatically make a bunch of random permutations of the code that are almost certainly going to make it fail. And then at that point, we can validate our test suite against that and see how often are we actually capturing those failures versus how often are we actually writing tests that don't do anything, just happen to run the code and give us like a nice code coverage metric, but aren't making sure our behaviors enforce what we want. So again, super great use on like the dev side, not on the like production side of a tool that you can use to do something you would have a lot of difficulty doing with some other, if you're just trying to manipulate this as a string, right? And this will do things like, oh, I'm going to switch these branches around, I'm going to invert these conditions, all sorts of good stuff. And again, here's some of the things that I've just been talking about. If you want to go back at some later point and check these out, that'd be awesome. Okay, so what's next for AST manipulation? What do I see as being problems? Well, number one, source mapping. If you're familiar with front-end development, you might know this term, but the essential conceit here is like I have some JavaScript and I want to minify that JavaScript, or I have some TypeScript that I want to compile into JavaScript. But when I run that minified version, I want to then be able to actually debug or see what's going wrong with the original code that I had, right? The same sort of traceback issue that I talked about before. The JavaScript community has solved this problem, right? We should just steal this. This is a serious hindrance to us using AST manipulation in production. Like I just said, neither dynamic or static AST manipulation has a good answer for this. So we should have a tool that lets us do this, right? Also, AST manipulation in general needs to be easier, right? The AST transformer, no transformer that I showed you earlier was pretty verbose, required you to know a lot about what's going on underlyingly, right? Not something that most people are really willing to dive into. We need something that's like the AST equivalent of find and replace that is super simple to use and produces good results. And then finally, this is sort of consideration, but backwards compatibility has not been great, right? If you think about the minor releases of Python that have been going on, there's a lot of new syntax added. Some of it's really awesome, some of it you wouldn't want to live without. But the problem is that although to most people that's like a totally unnoticeable backwards compatible change, on the AST level there can be very, very significant changes. And a lot of the tools I want to show during this presentation, I found out weren't compatible with 3.6, right? Which is a shame. We're losing out on a lot of what we could have, a lot of tooling we could have by not having some like intermediary form, right? That's a backwards compatible AST that will work over different versions of Python, for instance, or even just by considering more carefully what changes the AST will end up resulting in for different AST-based tools. So another area that moving forward, I think that we could really benefit from looking at. So let's talk about what you learned in this presentation. First of all, ASTs, easy, useful, tons of tools out there, right? Now you can go take this presentation, get started with stuff, start reading a little bit more about it, start using these in your own code bases, right? But more importantly, you also learned that I am a visionary, the likes of which an Elon Musk figure sort of would like to aspire to become one day. And yes, those posters are available online, just as an email. So here are my closing thoughts. Alan Turing once said, there need be there need be no real danger of programming ever becoming a drudge. For any processes that are quite mechanical, may be turned over to the machine itself. Beautiful thought, right? A thought that was expressed almost 80 years ago. And every time I find myself writing a bunch of boilerplate code, I cry a little inside because this is not where we're at right now. If this is still a place we want to get to, and I think it is, then we are going to need to have code that understands code. And ASTs are the best way of doing that. Thank you very much.
So, thank you, Chase, for this insightful talk. Hands up, we got some inspiration to clean up his own code base now. Quite a few people. Questions?
So you did mention that AST manipulation can still be quite tricky and it's packaging compatible and things like that. Do you think that Python would benefit from having macro syntax of some sort and exposing that more to the developer?
I really enjoy Python being a pretty minimalist language, although it's getting to be less so maybe. I don't think that is necessary to be built in. I think that we already have a lot of tools you need to do that if you wish to, and then if you don't want to get your hands onto any of this sort of stuff, then it's not something you have to worry about, right? So I like not having that capability in Python, just keep things simpler for people who don't want to mess with it.
Do you think we should go full JavaScript and have extra layers on top of Python then?
Maybe. I mean, so I think the thing that you might hopefully will take away from this is like, let's say there's a path you really liked that didn't go through, like a pattern matching or something, right? Or something you really need that's specific to your project but isn't universally applicable, right? You can do that through AST manipulation. So it could be argued that maybe for some domains, you have that extra layer that goes from something that's more appropriate to what you're doing to Python. Not a bad idea, I think.
So what problems at your company did you actually solve with those AST tools?
Well, I'm about to be crucified here, but not in my current company, but in a previous company, I was stuck with a Python 2.7 code base, which I know no one here has ever had to bury themselves with working with. However, I needed to have yield from syntax, which isn't in Python 2.7, and hopefully the PEP says, hey, do you know that yield from is equivalent to this block of Python code? So basically, more generally though, I've used AST querying and search more to do like custom linting stuff, which I found very, very, very helpful because Pylon, for instance, right, has some good general rules, but not ones that are going to be specific to your project. And then just on top of that, being able to do introspection to see like, oh, what's going on in this? I wrote something once that went through, like I said, a code base to see what are all the XPath expressions in this, which was based off how was the string being used in terms of what method was calling, things like that. So it's nifty to be able to pull out for those sorts of things.
Okay, thanks.
Hi. Do you have any experience with using full syntax-free tools like Red Baron or similar?
So I haven't personally, but I know other people who have. And that's, yeah, definitely, if you want to do the sort of static manipulation, full syntax-free tools will preserve sort of that white space, the colons, all that good stuff, so that the code you get out will be closer to what you originally put in. So I think definitely if you're going to be looking into doing static AST manipulation, that's the way to go.
Hi. There's CTX on load in one of the first examples. Are you doing AST dump? What does that mean?
Yeah, I don't actually know whether the Python interpreter cares about that, but basically it's giving you some context about, for a specific name node, there are a few different things that can be. The major ones are store and load, which represent whether you're loading that value from the environment or from the scope, or whether you're storing that into the scope, if that makes sense.
One final question.
I see you made a reference to SQL alchemy, and then later on you put a slide with pony.orm, and you suggested that pony.orm can generate SQL statements. Are you suggesting that SQL alchemy does not do it in the same fashion?
SQL alchemy doesn't, as far as I know, maybe I'm wrong, doesn't give you the ability to transform generators into SQL. Maybe I'm incorrect on that front. I haven't really kept up with SQL alchemy specifically. But if it does, that's awesome. And if not, I think Pony is a great tool for you being able to go to a code base, not necessarily even knowing SQL, but just use the Python that you know to be able to really guarantee that you're going to have valid SQL expressions.
Okay, so the next thing will be the lunch break. If you want, we can continue the question and answer session for a couple of minutes. There's still, I think, 2 questions.
You put the source mapping thing about in the next. So it means there is nothing now, or there is some preliminary project, or because that's the part I'm interested in. I mean, if I get an error, the line number, how to map that line number to my original code.
No, totally. I mean, I definitely think that it's a place where, as far as I know, the ecosystem is deficient, right? A lot of these things, most people wouldn't feel comfortable doing outside of like experimentation without being able to tell where's this error coming from. And as far as I know, there aren't any solutions for that in Python right now.
Okay.
PyTest doesn't go both ways, right? So PyTest will just produce for you the new code, and I think basically what they've done is test the code they generate well enough so you'd never have internal errors happening in that. I think it just keeps track of what line it replaces to show you the error on that line.
Great talk.
Thank you.
So there's a Haskell monad bind operator, which is represented by 2 arrows to the right and an equals.
Yep.
Can we support this in Python using the AST?
Yeah. I mean, you could, so it depends on what you mean by support, right?
It's not valid Python.
It's, oh, sorry, I understand your question. So that specific syntax, no, right? So if you're using the, at least if you're using the AST module, you're beholden to actually writing syntactically valid Python code, right? You could do something if you want to, like Scala has 4 comprehensions, which will basically do that sort of monadic binding. You have a similar thing in Python, right? Where you could say, I'm going to take this generator comprehension, run that, get the AST, and transform that into a series of flat maps and maps if you want to. But you can't support syntax that doesn't already exist in Python.
Thanks.
So let's thank Chase again for this insightful talk.
Welcome to this course on Practical Abstract Syntax Trees, or ASTs. Originally, when I was faced with making a change that affected hundreds of files in a codebase, I would question whether or not it was critical to make that change. If it was, I would then slowly go through each file and make that update. This would often take a long time and could be error-prone. After doing this several times, I learned ASTs unlock the ability to automate a lot of repetitive or challenging tasks like this in a much more reliable way. In the process, I also realized that ASTs have a much broader application than only refactoring. This course aims to distill the time I spent struggling through the documentation in a way I wish I could have learned about abstract syntax trees and the various applications in the front-end web ecosystem. When seeing or hearing the term AST, it's tempting to ignore it because it seems either irrelevant to the work you're doing or just sounds way too complex. After this course, hopefully you'll understand that neither of these statements are true. First, ASTs are more common than you may think, and are used in many examples of software such as Webpack, Babel, and Prettier. Second, ASTs can seem complex due to their vocabulary, tooling, or documentation. However, this course will take an AST first approach. This way, we'll first acquire a strong understanding of ASTs, then we'll start to interact with ASTs, and then finally we'll start to explore the tooling available for using ASTs in a practical way. This way, your AST knowledge can be applied to any AST-based tool. This course will start by covering the fundamentals of ASTs, what they are, and how they work. Once we're comfortable with ASTs, we'll start to explore several practical use cases, including code audits or static analysis to understand the current state of source code, code transforms or code mods to transform source code from one state to another, and finally code linking or rules to prevent certain patterns from appearing in source code. Most courses will build an app along the way, but we'll use a sample app because this course is aimed at practical uses of ASTs for maintaining and refactoring code bases. This course is for anyone who has ever needed to maintain or refactor a large code base. This course is primarily written in JavaScript and TypeScript and works on a JavaScript code base. Many of the concepts in the course are not JavaScript or TypeScript specific, but many of the tools will be specific to these languages. Let's get started. The first lesson will dive into understanding ASTs and how they work. What is an AST? This course is designed to provide a concrete understanding of the theory and practical uses of abstract syntax trees, or ASTs. Before we explore the practical uses, we need to gain a conceptual understanding of ASTs. At a high level, an abstract syntax tree is an intermediate representation of source code as a tree structure. But what does that actually mean? Let's break each part of this statement down. To start, let's look at the tree data structure. A tree data structure starts with a root node. The root can then point to other values, and those values to others, and so on. This begins to create an implicit hierarchy. It also happens to be a great way to represent source code in a way computers can easily interpret. Each one of these values, or circles in the tree, are referred to as nodes. The relationships between nodes are often described with terms like child node, parent node, sibling node, and so on. Like convention, the root node is shown at the top. However, if it's flipped, with the root node at the bottom and the rest of the tree hanging upwards, it starts to look like an actual tree, with all the branches forking out. Tree data structures are common in computer science and have many practical applications, such as searching and sorting data. There are also many different types of trees with different constraints. For example, a binary tree is a tree with at most two child nodes. For the purpose of working with ASTs, the important aspect is understanding how a tree can be used to represent data and the relationships between nodes. Some of the most common uses of ASTs are in compilers. A compiler accepts source code as input and then outputs another language. This is often from a high-level programming language to something low-level, like machine code. In the front-end web ecosystem, this includes tools like Webpack or Parcel. These tools compile many modules into a bundle and perform other optimizations such as transpiling from modern JavaScript to another version, or unifying the code by renaming variables and functions to short names. Although they are a little different to conventional compilers, they follow many of the same fundamental steps. Compilers are commonly broken down into two parts, the front-end and back-end. The front-end is responsible for scanning and parsing the source code, while the back-end is responsible for producing the output. One benefit of making this distinction is the ability to combine a different front-end and back-end depending on the input language being compiled and the desired output language. Additionally, breaking this process down into distinct steps makes it easier to reason about. In order for this to work, the front-end and back-end need some form of protocol or an intermediate representation of the input. Typically, the output of the front-end is an abstract syntax tree. The AST represents the source code in a tree structure, hence a syntax tree. It's considered abstract because at this point it has abstracted away syntax as irrelevant when represented by a tree, since it can imply things like hierarchy. While ASTs can seem complex, most of the complexity is in generating them from source code. Fortunately, there are many great tools in the JavaScript ecosystem that can handle generating ASTs. For the remainder of this course, it won't be critical to know the nuances of compilers or all the different types of tree data structures or the complexities of generating ASTs. However, understanding what ASTs are will unlock a whole new set of practical skills. For example, some common applications of ASTs include counting how many times a function, variable, component, or prop is used in source code, or transforming code from one syntax to another, or enforcing rules for syntax or other static analysis. For example, disallowing unused variables. Once familiar with abstract syntax trees, many of these concepts can be carried from one tool to another, as they will be built on many of the same fundamentals. Now that we have a base understanding of what ASTs are and how they work, what does a basic AST look like in practice? Let's take the following line of JavaScript as an example input. This code can then be represented by the following abstract syntax tree on the right. You'll notice there's a single root node. Here, that's the addition operator. In practice, the root node represents the entire file, but for the purpose of this example, unnecessary nodes have been omitted. Each child node, for example, the numeric literal 2, has one unique parent. This can be said for all other nodes in the tree except the root. Finally, the tree structure implies hierarchy, which means syntax such as parentheses can be omitted. For example, to evaluate this tree, the multiplication must occur before the addition. Looking at a visual AST like this can be a helpful way to understand the structure. However, this isn't the true representation of what an AST will be when working with it in later lessons. A more common format is to represent this abstract syntax tree in a JSON format. Using the same example code, a simplified JSON structure representing the AST can be seen on the right. Most tooling that relies on ASTs operate on a JSON structure like this. As the tree becomes larger and more complex, it can become harder to visualize the structure. Take a moment to relate the visual representation and its JSON format with the same tree. Visualizing source code in a tree structure like this is one technique that can be helpful when reasoning about ASTs. Here, the entire statement is considered a binary expression node with three primary properties: left, operator, and right. The left node is then a numeric literal node representing the value 2. The right node, however, is yet another binary expression node, again with the properties left, operator, and right. However, this time, the nested binary expressions left and right nodes are both numeric literals representing values 4 and 10. Now that we conceptually understand ASTs, the next lesson will cover what they look like in more depth. Manually exploring the AST is a helpful exercise in understanding the relevant subtree and its nodes which represent a given piece of code. Understanding relevant nodes is the first step to being able to automatically or programmatically traverse an AST. AST Explorer is one of the simplest ways to begin exploring real ASTs. It provides a UI on top of many tools and a way to interactively explore ASTs. This helps make ASTs more digestible by highlighting the relationship between the source code and specific nodes of the AST. To give this a try, we'll go to astexplore.net and put in the same piece of sample code from the previous lesson. There are a few views and settings AST Explorer provides in the top menu. First, there are the languages. For this course, the language can always be set to JavaScript because all of the example code we're parsing is JavaScript. The parser option will need to be changed throughout the course depending on the exact tool being looked at. For now, using Babel parser is a good default, and many of the first lessons will use this as the parser. This setting controls which parser is used to generate the AST. The final AST can differ depending on which parser is selected. Remember to switch the parser to match the tool being used in later lessons. Otherwise, the generated tree in AST Explorer can have subtle and confusing differences. Next to this parser option is a gear icon. Clicking this controls the options for the selected parser. For example, pasting in something like TypeScript code would require enabling the TypeScript plugin and disabling the flow plugin, but the defaults are fine for this case. The left pane is the code editor. This is where any relevant code can be typed or pasted. Typically, it's easiest to keep the code as short as possible to keep the generated AST small, so it's easier to explore. The resulting AST for the code snippet will be generated and visible on the right. Each node in the tree can be expanded or collapsed. Arguably, the best feature is the ability to click on the source code to highlight the exact node in the tree view. Clicking the node in the tree view will also highlight the relevant code in the editor. For example, clicking forward in the code editor will highlight the numeric literal node in the tree view. Or hovering over the numeric literal node with a value of 10 in the tree view will highlight the number 10 in the code editor. Alternatively, the entire generated tree can be viewed as static JSON by typing the JSON tab to the right of the tree tab. The tree view also exposes several other settings. For example, the location data, which defines the lines and columns where the code originally appeared in the source, isn't frequently used. The hide location data option can be enabled to hide this data in the nodes and make it easier to explore. Hide empty keys will hide keys with undefined values. These settings are necessary, but can make it easier to focus on the important pieces. Take a moment to explore ASTs generated for other code. For example, maybe paste a snippet of code from one of your projects, or consider pasting a snippet of code from an open source repo. Otherwise, maybe try different types of syntax, such as spread syntax, knowledge coalescing, or optional chain. AST Explorer is a helpful tool when trying to understand the AST for a given piece of source code. Keep it handy to paste in any pieces of code that come up through the course, and remember to double check settings. We now have a base understanding of what an AST is and how to manually explore one. The next lesson will cover some of the tooling that exists in the JavaScript ecosystem for working with ASTs. ASTs are not unique to JavaScript, but there is a robust ecosystem of JavaScript-specific AST tooling available. You may even be familiar with some of them, or already use some of them on a regular basis. This lesson will quickly cover some examples of the JavaScript-specific tooling that either rely on, interface with, or expose ASTs. ESLint is a JavaScript code editor. It provides a way to define rules for the code to follow. It relies on converting the source code into an AST and then traversing the nodes to verify there are no violations. This means if you're familiar with ASTs, it's possible to create custom linking rules. This will be covered in more depth later in the course. Babel is a JavaScript compiler. It's commonly used to transpile new JavaScript features to backward compiled JavaScript. It provides several packages to work with code at different steps. For example, Babel parser converts a string of code into an AST, or Babel generator converts an AST back into a string of code. This will also be covered in more depth later in the course. JS Code Shift is specialized tooling for transforming JavaScript. This is primarily used for one-off code transformations when breaking changes made across large code bases. For example, all the React code mods are built with JS Code Shift. This will also be covered later in the course. Cursor, a JavaScript parser and compressor or minifier. Finally, Prettier, an opinionated code formatter. It relies on ASTs for formatting source code. This is only a short list of some of the tools available that work with ASTs in some way in the JavaScript ecosystem. The remainder of this course will dive into a few of these, looking at how they can be used in practice. Many of the concepts can be carried from one tool to another since they're all based on ASTs. This lesson quickly covers some of the environment tooling used throughout the rest of the course. If you're comfortable using replacements, for example, yarn instead of npm, feel free to make those adjustments. This course was created with Node version 12 and npm version 6. However, any recent version should be sufficient. A quick way to check your version is to run node-v in your terminal.
If you don't already have Node npm installed, follow the steps for installing them using the Node version manager. This allows you to install multiple versions of Node and seamlessly switch between different versions. Any editor should be sufficient for this course. However, I will be using VS Code because it has great TypeScript support. Similarly, any terminal should be sufficient to run the scripts with Node, such as iTurn 2 on Mac or Windows Terminal in Windows. Now that we have a base understanding of ASTs, some of the ecosystem tools we'll need, the next lesson will dive into generating ASTs. Now that we have an understanding of what abstract syntax trees are, we can start generating ASTs from source code and programmatically traverse through different nodes in the tree. When previously looking at AST Explorer, the parser option was set to Babel parser. This is a package that's available on NPM, which means you can install it and use to parse any source code string into an AST. At a high level, Babel is a JavaScript compiler commonly used to transpile modern JavaScript syntax to compatible with older JavaScript syntax. This allows early adoption of new syntax and features before there is sufficient browser support. It has a robust plugin system that can be used to add support for many different syntaxes. For example, the optional chaining plugin. This adds support for optional chaining syntax, which is new syntax that isn't ready supported by browsers yet. This will transpile this new syntax into equivalent but older syntax. Or the React.js plugin, which adds support for JSX, which is XML-like syntax and not intended to be implemented by browsers. This plugin transpiles the syntax to an equivalent and supported syntax, specifically functions and objects, before it be ran in the browser. And the final example is the TypeScript plugin. It adds support for TypeScript syntax, specifically static types. This plugin inserts the types and does other transformations to transpile to valid JavaScript. These are only a few of many plugins that Babel supports. Babel performs these translations by converting the source code into an AST. It manipulates the nodes and converts the manipulated AST back into source code. These plugins can extend and modify the parsing and generating of the AST. This means it's also possible to write custom plugins. The Babel core package wraps up most of this functionality in a single package with minimal configuration. However, Babel also exposes the different internal operations and functionality in a series of packages. We'll be using several of these packages in this lesson and throughout the rest of the course. The Babel parser package parses the source code string into an AST. The Babel traverse package allows us to traverse different types of nodes within an AST. The Babel generator package converts an AST back into a source code string. The Babel types package creates new nodes to add or replace existing nodes in an AST. All of these lower-level packages can be used to create flexible custom scripts to parse, generate, and manipulate ASTs. To get started, we'll focus on the Babel parser package to parse the previous code snippet into an AST. First, create a new Babel parser demo directory. Then change into that new directory. Next, we'll initialize a new package.json file. And finally, we're going to install the Babel parser package. Now we can open this project in our editor. Next, create a parser.js file that we'll use to execute the parser on the source code. First, import the parse function from Babel parser. Then we can create a variable with the same example code from previous lessons. Now we can use the parse function to parse the code into an AST. Now that we have the AST, let's print it. Switch back to your terminal, and now we can run this with Node. We can see that this printed the same AST. This AST is a single file node with several properties. One of the properties is program, which is a program node. This program node also has several properties, one of which is body. The body property is an array that can contain various types of nodes. This is where the nodes that represent the code we parse will be. Note that AST are deeply nested, so the output is truncated after a few levels. Let's switch back to our editor and we can update the script to log the first node in the body of the program. This is the part of the tree that represents the example code. As we just saw, the AST had a program property, which itself had a body property, which is an array of nodes, and we want to specifically look at the first node in that body array. Now we can switch back to our terminal and run this again. This time, the parser script only printed the first node in the program body, which is an expression statement. This node has an expression property, which itself is a binary expression. A binary expression node has three important properties: left, operator, and right. In this case, the operator is the addition sign. The left property is a numeric literal node with a value of 2. However, the right property itself is another binary expression node. This second binary expression operator is a multiplication sign, and both its left and right properties each point to a numeric literal node representing 4 and 10. Compare this output with what you saw in AST Explorer. AST Explorer and the script are both using the Babel parser package, so the output should be identical, assuming all the configuration is the same. Now that we know how this part of the tree looks, let's update the script to print only the first binary expression's left numeric literal value, which is 2. The script is already printing only the expression statement. As seen earlier, the expression property is a binary expression which has a left property as a numeric literal node. The numeric literal node then has a value property with a value of 2. Now we can switch back to our terminal and run the script again. This time, only the value 2 is printed. Instead of logging only the leftmost value, take a few moments to try to update the parser script to log all the numeric values in the expression: 2, 4, 10. For now, assume the tree never changes. In the next lesson, we'll explore how to do this in a programmatic way to handle any arbitrary tree. In the previous lesson, we wanted to log all the numeric values in the source code. This lesson will continue to build on that, but explore how to do it in a more generic way. The resulting script may have looked something like this. We had 3 print statements, one for each of the numeric values in the tree. However, what would happen if the order of operations was swapped in the source code to do the addition first, then multiplication? Changing the order of operations like this will result in a different AST. Previously, 4 and 10 were multiplied first, then added to 2. Now, 2 and 4 are added first, then multiplied with 10. We can see that this new equation produces a different tree from the previous lesson. Now, the new tree has a binary expression on the left and a numeric literal on the right. This time, the first binary expression node has another binary expression node on the left instead of the right, and a numeric literal node on the right instead of the left. Additionally, its operator is now a multiplication sign. Each type of node only defines properties relevant to what it represents. For example, a binary expression node has an operator property to indicate either addition or multiplication. However, a numeric literal node does not have an operator property since it represents only a number, but it does have a value property, which a binary expression does not. Each property can have several different types of values. For example, the numeric literal value property is always a number, whereas the binary expression left and right properties are always another node. As seen in this example, the left and right properties can be more than one type of node. In this case, either numeric literal or another binary expression. The parser script made assumptions about the structure of the tree and the types of nodes. It assumed the first binary expression had another binary expression in the right property, and that binary expression had a numeric literal in the left property. Looking at the new tree, we can see this is no longer the case. Now, the binary expression's right property will return a numeric literal node instead of another binary expression node. Then, trying to access the left property will return undefined since left doesn't exist in a numeric literal node. And finally, trying to access the value of that undefined value will throw a runtime error. Now, let's switch to our terminal and run the script and see if that's the case. We can see that this line indeed did throw a runtime error as we expected. In order to fix this issue, we need to make our script more flexible. We need a way to generically visit a specific type of node in the tree wherever in the hierarchy it may be. We want our script to be more flexible in order to handle any AST, or in other words, any source code input. The Babel traverse package offers the functionality to programmatically visit nodes anywhere in the tree. In our case, we want to visit the nodes that represent the numeric literal. We'll continue with the existing project from the previous lesson, and we'll get started by first installing the Babel traverse package. Then, we'll switch back to our editor and create a new traverse.js file that's a copy of parser.js with one new import from the traverse function from the Babel traverse package. The parse method is a named export from the Babel parser package, but the traverse function is the default export of the Babel traverse package. And we can also remove the print statements. The traverse function expects an AST as the first argument, which we already generated with the Babel parser package. The second argument is an object of visitors. Each key in the object is the type of node to traverse or visit. Each key's value is a function invoked for each node of that type in the AST, also known as a visitor. The traverse function will visit each node in the AST. For each node, if there is a visitor defined for that node's type, it will be invoked with a node wrapped in a path object. The underlying AST node can be accessed via the node property on path. ASTs consist only of nodes, but most tooling will pass the path object of visitor functions. It's a wrapper around the node it represents with some additional helpful metadata, such as a reference to the parent node. Terminology like this is why ASTs can seem complex. It's helpful to be familiar with these terms since most tooling documentation will use them, but it's more important to understand the concepts. The actual code in this case is fairly simple. We want to find all numeric literal nodes in the AST, so we define a visitor for nodes of that type. Now let's run the script to see what this prints. The script printed all of the numeric literal value nodes, but we only want to print the values. We can switch back to our editor and update the visitor function for numeric literal nodes and only print the node's value. Now running the script will produce the same output as the parser that manually printed these values. Unlike the previous script, it will handle any source code and will throw a runtime error. The output order is maintained because traverse will visit node step first. Additionally, traverse will invoke the visitor when traversing down the tree or on enter. It's also possible to define a visitor that will be invoked when visiting the node when going back up the tree or on exit. Let's quickly define a visitor for numeric literal nodes that will print on both enter and exit. Running the script again will now print twice for each node. In this case, all of the numeric literal nodes are leaf nodes or don't have any children, so the exit will be invoked immediately following the enter. Changing one new visitor node won't be necessary for any of the examples in this course, but it can be a helpful technique depending on the use case. We can revert to the original visitor function for now. Take a few moments to try updating the source code input with several different equations, and notice how this approach can handle any potential input now. I'll quickly paste in a new equation and show how it prints all of the numeric literal nodes in the equation. After you've tried a few different equations, try updating the script to print only the operators instead of numeric literals. The expected output for the original source code example would be the addition sign and then the multiplication sign. Make sure that the two can handle any equation. If at any point you get stuck, don't forget about AST Explorer. Once you've updated the script, take a moment to consider how you have found all the numeric values or operators with a traditional search tool or find replace tool. This example is simplified, but you might imagine doing something similar if you want to know all the usages of X in the codebase. The next module will begin to explore how these types of questions can be answered with ASTs. Before that, the next lesson will quickly cover one more tip for creating custom traverse scripts. In the previous lesson, the initial script for logging the numeric values worked for one specific code snippet. Updating that to another code snippet resulted in a runtime error because the underlying ST changed. The first step we took was to use the Babel traverse package, which allowed us to more generically visit nodes within the tree. Ideally, this issue with the initial script would have been caught before the script was even ran. Fortunately, many of these issues can be caught in your editor or at compile time with TypeScript. The type definitions define all the nodes in each node's specific properties. This means only valid properties can be accessed. Additionally, since many properties can be polymorphic or point to many other types of nodes, it requires narrowing the type to only the nodes with that property defined. This results in many more runtime checks and an overall more robust script, leading to fewer runtime errors. You can think of the AST that the type definitions represent as the most generic AST, since it represents every possible node and property. Keep in mind that TypeScript is not a requirement for any of this, but it does help avoid runtime errors and provides code completion, which makes it easier to work with complex nodes. So the rest of this course will continue to use TypeScript for our scripts.
Then keep coming closer. There's an ocean full of stars. You hold on tight, and let your heart explore. Would you like to know who you are? Then keep coming closer. Would you like to know who you are? Then keep coming closer. There's an ocean full of stars. You hold on tight, and let your heart explore. Would you like to know who you are? And keep coming closer, 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 closer. through you. I wanna be thrown into your tide. I wanna become like you and move the way you do. I wanna be thrown into you and go wild. Sirens flicker around your head tonight. You
Mummy, who would I have been if my father had been someone else? You see, the child gets the idea from our culture that the father and mother gave him a body into which he was popped at some moment. Whether it was conception or whether it was parturition is a little bit vague. But there is, in our whole way of thinking, the idea that we are a soul, a spiritual essence of some kind, imprisoned inside a body. And that we look out upon a world that is foreign to us. In the words of the poet Hausmann, I, a stranger and afraid, in a world I never made. So therefore we speak of confronting reality, facing the facts. We speak of coming into this world. And this whole sensation that we are brought up to have of being an island of consciousness locked up in a bag of skin, facing outsiders, a world that is profoundly alien to us in the sense that what is outside me is not me. This sets up a fundamental sensation of hostility and estrangement between ourselves and the so-called external world. And therefore, we go on to talk about the conquest of nature, the conquest of space, and view ourselves in a kind of battle array towards the world outside us.
I don't understand why he's not removing the keys from the dictionary. The problem is that I'm setting this one after as well, because it's capturing the stuff that is running here. But that's an issue, I think. I think I should put this set trace none instead of this thing here. Or before everything. Actually both. So both here and here, I think.
Now, actually, it is absolutely absurd to say that we came into this world. We didn't. We came out of it. What do you think you are? Supposing this world is a tree. Are you leaves on its branches? Or are you a bunch of birds that settled on a dead old tree from somewhere else? Surely, everything that we know about living organisms from the standpoint of the sciences shows us that we grow out of this world. That we, each one of us, are what you might call symptoms of the state of the universe as a whole. But you see, that is not part of our common sense. Western man has for many centuries been under the influence of two great myths. When I use the word myth, I don't necessarily mean falsehood. To me, the word myth signifies a great idea in terms of which man tries to make sense of the world.
I think it's just capturing this stuff as local variables there. But I don't understand why it's not deleting the ones that I specify here. It's capturing the other ones. I also don't understand why it's capturing there if I'm setting the trace to none. I guess it's because, yeah, but once it hits the exception, it should stop the tracing, which means it should stop appending to this stack frame. So maybe on the last frame, when it catches the error, that frame still goes into the sys trace. Because it's the one that is capturing the thing. I don't understand why it's not deleting here as well. Because in the examples, they don't make it equal or like create a new object. This should delete from the original one. And the key is the same here, so. It's probably something to do with the way that this function interacts or whatever. Yeah, now it's deleting, so it was the other parts. Because this probably is not enough, because it still captures the other frames. I don't know, when you use this stuff here. Because here I'm appending to the other list, so it shouldn't be printing here. That's what's weird about it. But I guess when it's tracing back, it probably goes over the function as well. Even though I set the trace to none here. Because they're still on this stack, maybe. I guess that's probably what happens. But when I set through none, it should stop, I think. So I understand why it doesn't. And now there's no local variables here. And so I guess the other one's capturing the local variables based on the exception. It's probably something to do with the way that it executes. Trying to think about a way to remove the... Because if I remove my file name, then I'm gonna remove some parts of the code, I think. The execution of the code. I'm gonna remove this for now, so just so I can see what happens. I'm still getting nothing here. I think this time we should be getting the variables from the IDE. Yeah, weird. That's because it's hitting the exception. And so it wasn't working before, probably. I'm still having the same problem that I was having. Or this stuff doesn't work for whatever reason. I'll just restart the server. It looks like it is right, the AST. It must be the execution. If I remove the file name from here.
Now, the two images which have most profoundly influenced Western man are, number one, the image of the world as an artifact, like a carpenter's table or a jar made by a potter. Indeed, in the book of Genesis, there comes the idea that man was originally a clay figurine made out of the earth by the Lord God, who then breathed into this clay figurine and gave it life.
You should let it break, just see what happens.
The whole of Western thought is profoundly influenced through and through and through by the idea that all things, all events, all people, all mountains, all stars, all flowers, all grasshoppers, all worms, everything are artifacts, and they have been made. And it is therefore natural for a Western child to say to its mother, "How was I made?" That would be quite an unnatural question for a Chinese child, because the Chinese do not think of nature as something made. They look upon it as something that grows, and the two processes are quite different.
Because the problem is probably that this string is not formatted in the correct way. Like I need a way to reliably format the string that I get from here. Also, I need to fix the thing that after 32 lines, it becomes multiple trees instead of an array. I will focus on this later. Yeah, so it is a string. What if I hard code this there? That's the issue. It's 509. So probably was the error that I was getting before. The issue is that I don't want to create a file. That's the problem. And I think if I just put execute, it's not gonna work with the stack frames. I think I'm gonna try that. You execute the tree directly. Or the string directly. The tree doesn't work. Yeah. Again, the same error. What can be this? This problem.
As we study man or any other living organism and try and describe it accurately and scientifically, we find that our normal sensation of ourselves as isolated egos inside a bag of skin is a hallucination. It really is. It's absolutely nothing. Because when you describe human behavior, or the behavior of a mouse or a rat or a chicken or anything you want to describe, you find that as you try to describe its behavior accurately, you must also describe the behavior of its environment.
But if this way is not working, then we probably use something else, not the string. But I don't understand why the exception would be the code string. There should be something related to that. It's probably not this, but it's worth trying. Because here there is no indentation in this code, so it shouldn't be that. Doesn't make sense. And this way my concern is that it can be the file name as well. So how can I solve this?
You were all I need. I was incomplete. You were there for me. You were all I need, and I wrote it like a promise. You were all I need.
Let me put a more simple thing. Like A equals 10 or something like that. And see what happens. Okay, I'm pretty sure that it's hitting this exception here after it tries this thing. The problem is that I don't understand these two functions really well yet. And they don't have source code on the IDE because they are part of the built-in library, I think. So it's just the definition here. I think this was the same mistake that I was having before. And then I thought that I wasn't getting the mistake because I had the other thing there and I didn't realize. Because I was getting the frames, so I thought that it was working. But I didn't realize that this could cause the like additional stacks should be placed on the trace function here. So the information that I was getting before was probably from this part of the code here, and not because this was working. So this was the problem that I had before that I was trying to understand, and that's why I was studying the functions. So I think I understand now, like what is a... I knew before what was a abstract syntax tree. I just didn't know like the structure of it, because I remember studying compilers and things like that. So I understood like I knew the concept, but I didn't. Now I think I understand like not very well, obviously, but the basics of how it works. Just a bunch of nodes, and then each node is gonna have like depending on the rules of the language is gonna have the path of the tree, and then the order of traversal is gonna be dependent on the rules of the language as well. So you have the variables, and then you have the operators, and each one is a node of the tree. And the way the language traverses the tree is gonna determine how it executes how it compiles the program. So I understand that, and I understand like here I'm creating the sync. Like the thing that is weird is that if it was because of the input, then I think that this wouldn't work, because I can test. I think I can just pass something that it doesn't work and then see what happens. And that's what I'm gonna do. But then there is creating an abstract syntax tree, and then here it compiles that abstract syntax tree. So what this does is the stuff that I was trying to study here through the source code. It probably just traverses the tree and then follows the instructions according to the rules of Python. And then the resulting is the binary code that is executable. And then the execute function executes the code. So it could be the file name, it could be the tree, it could be the compile. Like the way that these things interact, and it could be the execute or exec. So like it's gonna be a pain in the ass if I have to figure out, because like for each input it's gonna be like I'm gonna have to create something similar to an interpreter or something like that, because each input is gonna have a different indentation. Like I'm gonna have to figure out the rules for it, like indenting the code correctly. After each character like this, put this amount of spaces, stuff like that. It's gonna be very difficult, I think. So I think it's probably not the smartest approach. I think the best way is trying to use this AST to create the tree and then execute. It makes more sense, I think. Or one of the other libraries that ChatGPT talked about there, these libraries here. Indentation is a pain in the ass. Let me restart this just to make sure. I'm gonna test with a simple input and then with an input that doesn't work. It still received this. Now let's test with something random. Yeah, it's still the same thing, so it shouldn't be the string. I think. Otherwise, I should probably get 2 different errors, I think. Yeah, but it's weird that when it doesn't work, but it could be the case that it doesn't work. Like that it is the string. And it just shows the same error. I think one thing that I can try as well is just remove the new line from here, but I don't think that's the problem. Because I think you need threads when you're constructing the thing. The other thing that I can do is just send the list, because through here it's easy to get, because of the way that the editor works, it's easy to get the lines. It's just gonna, each line is one element of the array. So I could send the array instead and then format in the backend on the server. But I think this is not a problem, I think.
Instead of feeling that we, each one of us, are something that the whole realm of being is doing.
Yeah, it doesn't change anything.
Something that has come into the whole realm of being.
And it makes sense that it's not the thing, because the other just have one line as well of code, so.
But we don't remember. And we think when we die,
Yeah, but it could be because of the, it would still be a part of the, oh, now it's different. Invalid decimal literal.
people don't really believe that.
Yeah, so it is in this string, because this is the error probably you get when the string is not formatted correctly.
They go to sleep and never going to wake up.
No, but here I also get the same thing. Yeah, so inserting the n is probably the correct way. So it's probably something else other than the string. Then I'm gonna have to understand. Because if I send again, it's gonna show the code string, blah blah blah. A code string. It's weird. Yeah. So, what the hell can be this? Oh, obviously it's not on the AST. It could be the file name. I put editor trace. Actually, let me study this before. It's probably better. I think I already read this thing. Well, the source into a code or ST object. Well, the objects can be executed by execute or eval. Source can either be a normal string or a byte string or an ST object. File name argument should give the file from which the code was read. Pass some recognizable value if it wasn't read from a file. It's commonly used. Yeah, so I think it doesn't matter like what name you put there. But I guess I'll just leave like this. the way that it is here, because this is the file where it's at. So I'll try like this first. But I think it's not gonna solve the issue. It's probably something else. Yeah, code string, same shit. Yeah, file, editor trace. I think it's not that big of a deal as well if I leave this stuff on the visualization, because like it doesn't matter. I think there's nothing that people can do. Like yeah, it only matters if like it is a bunch of code, but I think it's gonna be always kept to the first stack or the first few stacks or first three stacks. But maybe I'm wrong. The only way to know is to test a bunch of codes, I think, a bunch of different input. Also, I just realized that if it was the string, then I think it's more likely to give this exception here because of the sanitize. So you would hit something here, I think. Although this is just to check to see, or it just wouldn't run because I removed the exception, but it wouldn't run this part. I think we just print the code. Yeah, I think like you would fail on this point here. We'll give this syntax error. But maybe that's what, no, that's not what is happening because I modify here, so I know that it's hitting this one. So maybe I should put syntax error here, just in case. So I have to understand more how I'm just gonna go one by one, otherwise I'm gonna get lost in this. There's so much stuff to learn. Python, C Python. I think it's possible that it is on inside of the folders because this happened with ChatGPT before. It just gives the file name, but it's not on the level that it said it would be. So I'm gonna look into this one by one. Maybe it is here. Python, C Python. It's not the correct one, but compile C. Yeah, this is probably the stuff that is gonna traverse the tree. Traverses the tree, and then based on the set of rules here, is gonna create the executable. I don't know much. I know some C++, but obviously not very good, very well. And C, I know that C is just C++ without objects, without classes. But I don't know really well how it works. There's also the chance that it's something related to executing this inside of the sys trace. Maybe I should try to execute before and see what happens. And then I just return here. Interesting. Cannot unpack non-interval, non-type object. So I guess this is returning none. Yeah, the reason why there are shows done is just because when you execute inside of the sys set trace, something changes and makes the mistake show up differently. I don't know why though. Oh no, it's not. It's because of this thing here. Yeah, never mind. So it's probably working. It's probably working here. Interesting. So now he's just executing. So the issue is neither. But why is hitting the exception there? It doesn't make any sense. Doesn't make any sense. Maybe it's inside of here. Inside of this function. Maybe it's because I'm deleting and some of them don't have these things. Yeah, if code string, nothing. Code string of variables. I think that might be the case because the exception should be. Let's see. Even if it's not, I think this is better to do it. Hope this works. Guys, it's working now? But it's still showing stack frames. Trace func. Which is weird. Because I'm pretty sure that I'm deleting them here. Yeah, stack frames. Trace func. So why is not removing from the object? I think I have an idea. Just put keys here instead. I don't like this playlist very much. Because ideally I only want to show the variables related to the script on the front end and not this stuff that I have here. Obviously. And it's still showing this. Why is it not deleting? So weird. I think it's because they are objects, like there's something with the memory, maybe. So when it tries to delete, it doesn't find because it's a reference or something like that. It's the only thing I can think of why it's not deleting, because the other ones are being deleted, so I guess the only guess is just the data structure. I think I'll be back. It's almost time. Let's see. I think it's gonna be kind of hard to find videos that explain very in depth these kinds of things. Yeah, so what I'm gonna do is probably watch these videos. I think I'm gonna watch videos and then meditate for 10 minutes, I think, before I keep going again. I think I'm gonna try to stay for a longer time, so probably 7 or 8 hours today. I'll focus on this file as well. Is enormous, so it's gonna be really hard to understand. Maybe it's a waste of time. Yeah, I think I'll do this later. I'll focus first on trying to make it work, because there's so many things to do still. So I just gotta I wanna make it work the simplest way possible. Just visualize the script, the stack frames of the script. Maybe it's better because this stuff is gonna be more complicated to try to connect the AST with the execution with the stack frames. So maybe the easiest thing to do is just visualize the script, then fix the stuff so that regardless of the size of the script, it gets the information in the correct way. Which might be hard because I might have to code some tree algorithm to get all the strings, all the lines from the nodes that the editor creates. Then after that, after I have the visualization, then after I set up everything, then I can focus on the visualization and changing the library from 3JS to Pixie.js. Yeah, that stuff's probably the main priority. So just work on this until I have something that it works with a bunch of different inputs. And then build the visualization, and after that spend a lot more time focusing on the visualization first. So I think that's what matters the most for people that are gonna use. And this stuff here is just like extra stuff that I can do in the future. Different types of visualization, things like that. Pretty interesting here. $2,000 people. Crazy. I guess the other thing that I can do here, since this thing is not working, I can build a dictionary from scratch. I think that's what I'm gonna do. Instead of using the local variables, I created another dictionary. And then I make these conditions, and if it's not, yeah, but then like the issue is that it might be the condition itself. So, but I think I'm gonna try like this just to see if it is the delete statement that is messing this up. So then, like inside of here, if it's not either one of them, then I create the variable. And the problem would be the name though. I guess I would just I'll loop over the items on the local variables, and then I just create on the other one based on the conditions here. That's what I'm gonna do. But I'll be right back, and then after, I think I'll watch these videos while I eat something, and then I'll meditate for 10 minutes, I think. So I'll be right back.
What is going on, guys? Welcome back. In today's little video, I'm going to show you how you can easily compile and also decompile or uncompile Python scripts. And this is not the same as taking them and turning them into executable files on Windows, so not the same as Py to Exa. I have a video on that as well. Today, we're just going to turn Python scripts, readable Python scripts, into compiled binary PYC files, and the other way around. So this is actually not an effective way to make the code unreadable, to obfuscate it. It's more like compiling and decompiling is easy, so you can basically turn this binary file back into readable code. It's not making your code in any way secret. So what you need to do for that is quite simple. You come up with a basic Python script. So for example, x equals integer input, enter the first number. Then we're copying that, changing it to y, changing that to second. And all the script does is basically just printing x plus y. Very simple script, and we can now run this like always in PyCharm, and you will see that I can enter 20 and 30 and I get 50. So what I can do now is I can open up my command line, so CMD on Windows or the terminal on Linux and Mac, and I can navigate to the directory. In this case, it's this directory here, so this path on my computer, and here you can see that I have this main py file. What I have to do now is I have to say python-m and then py_compile, and for that you don't need to install anything. This is part of the core Python installation, and then I just pass main.py. So that's basically it, and now you can see that we have this PyCache folder. Now by default, I think in PyCharm it's not displayed, so the individual PYC files are not displayed. You have to turn it on in the settings to see that here on the left, but the file exists, and all you need to do now, for example, in the command line here, is to go into that directory and to say python main.cpython39pyc, and you can see that I can do the same thing here. Now, in order to turn this back now, or first of all, I can show you that you can open this, and this is basically a binary file. You can read a couple of things, for example, the strings here, but you cannot really see, you have a bunch of bytes that you cannot really read here. So if you want to uncompile that, you need to install a tool called uncompile. Actually, I think it's called uncompile 6, so you need to go to your command line, and you need to say pip install uncompile, like that, py like Python, not like it's actually written, 6. Pip install uncompile 6, and if you now want to uncompile something, you just type uncompile 6, and then, in this case, main.cpython39pyc, and then this greater than symbol, and then uncompile.py. Now, in this case, however, at this point in time, it's not going to work, because this tool does not support Python 3.9 yet, which does not mean that you can use this technique to obfuscate your code with Python 3.9. It's just a matter of time. Sooner or later, it will be possible, or it is already possible, but you just need to do it in a different way. You can't always decompile it, so it's not like you're making your code unreadable, and there's no way to reverse this. It's just that this tool does not support Python 3.9 yet. So if I run this, you're going to see unsupported Python version. Doesn't mean that Python 3.9 is now a version where you can do that, and you don't have to worry about anyone reading your code. What you can do, however, is you can also do this with Python 3.8, and I'm going to do this on Windows Subsystem for Linux now here, because there I have Python 3.8. You don't have to be on Linux, so you can do that on Windows as well. You just navigate to the neural directory or to whatever directory you are working in, and then you type python 3-m py_compile main.py, same thing. The difference here, of course, is that Python 3 in this case means Python 3.8.10. Come on. And now I can go to the directory here, PyCache, and you can see here that I now have this cpython 3.8. This was 3.9, this was the one on Windows, this is Python 3.8 now. So I can also just go ahead, Python 3 main.cpython38pyc. I can run the same thing here, you can see it works. And now actually, if I go ahead here and I say uncompile 6 main cpython 3.8, so the version that is supported, and now I'm going to call this decompiled.py. There you go, you see it worked. So now I have this decompiled py here, and you can actually see that we have a bunch of comments here, but at the end of the day, this is the code. Actually also with the same parameters, with the same variable names. And actually, this can be done with way more complicated scripts. So for example, let me just go to my prepared folder here. This here is one of the videos that I already made, the paint clone in Python, so I can just copy paste this here. There you go, paste. Main 2. This is basically the neural 9 paint clone. I have a video on that. You can check that out if you want to. If I just run the Python script, you're going to see that this is the only file we need for that. I can draw here, I can save, I can increase brush size, I can choose colors and all that. So all this works, and I can now compile this. And you can see that I have very specific names, paint GUI, and I have safe btn, clear btn, and so on. And I can go ahead now and compile this here on Linux with Python 3.8. So basically just python 3-m py_compile main2.py. Then I go to the PyCache. You can see that I have this now here. And I'm going to run this on Windows, because otherwise I'm going to need the GUI support, and I don't have my Windows server running at the moment. We need main 2. What's that now? Python main 2. Okay, we have a problem. Yesterday it worked. So let me just fix that. I'm going to come back to you. All right, now I'm not sure why exactly this is the case, but if I type Python main 2, it has that magic number, but if I type main 2 directly, it runs the compiled version. So you can see it actually works. And we can also go into, I closed this actually. We can also go to Subsystem and see that the generated file is basically binary and unreadable. At least for us. We can see a couple of strings here, but basically a lot of bytes we cannot really decipher as a human. And what I can do now is I can just uncompile this. So I can say uncompile 6 main 2, whatever, and then paint clone decompile.py. Take some time, there you go, and now I have this paint clone decompile py with a couple of comments, but you can see that I have the exact same code. Now, maybe some formatting issues, but we have the same names, we have the same functions, we have the same strings, so it's not really about making your code unreadable or safe or secret or anything, it's just compiling for whatever reason you want to compile your files, but keep in mind, when you compile a Python file like that, you can also decompile it, and again, this is not the same as turning a Python file into an executable file, it's a whole different thing you're doing. I have a video on that as well. If you want to know how to convert Python files into executable Windows files, check out my video on that. This is how you do basic Python compilations or compilation, and how you also decompile or uncompile back into readable source code. So that's it for today's video. If you enjoyed it, I hope you learned something. If so, let me know by hitting the like button, leaving a comment in the comment section down below, and of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you so much for watching, see you in the next video, and bye.
Hey Thinksters, what's up? It's Chris, founder of Things.com, and in today's video I'm going to show you the Python compile function. So this is one of Python's built-in functions, and the creators of Python, they have maybe they've created maybe 30 functions that are built into the Python library, so you don't have to import these functions to use them. And that's why I think that every Python coder that is at least intermediate level should have seen all the Python built-in functions, because Python's creators thought that these are the most important functions that need to be included in the Python standard implementation. And so let's dive right into the function. What does it do? How does it work? So Python's compile function, it compiles a string, so it takes a string or a textual representation of code and compiles it and creates an executable representation of the string. So it's much like the compile method in any other programming language. It's actually you can make explicit what is implicit, what is implicit in any programming language. So if you create your own code, you basically write the code in a code file. But now if it is in a file, it is only a textual representation of code. It's only text. It's only a string. And the compile function takes this string and compiles it and creates a so-called abstract syntax tree or AST object, which is an executable code object. And now you can take this object and run it in your Python code. And this is a great function because it allows you to at runtime to create code dynamically. So your code can basically write code and compile the code down and execute the code. And all this can be done dynamically as your code runs. So for example, you can allow a user to create some code and then take this string representation from the user, compile it down and run it in your code. Or you can even create a machine learning model. There's nothing against it, so you can create a machine learning model that creates its own code, that writes its own code, and then you can at runtime while the code runs, you can compile this string representation and run it and execute it in your shell. So it's very powerful. It's a very powerful meta function that allows you to do these dynamic code compilations. So how does it work? Maybe let's have an example. So say we have the following 2 lines of code. So say this one. Yeah. So we have some. Maybe let's open the code file. Okay. So say you have the following 2 lines of code. Here you have you create a dictionary, customers, where you map Alice to the value 40,000, could be $40,000 or something. Then you have Bob, and you map Bob to $33,000. Now you print the dictionary content of Bob. So you use the F string, format string. It doesn't really matter what we do. It's just we have some lines of code, and now we want to. So this is like you could execute this code snippet, just run it out of the box, and you see the result is Bob 33,000. But now what you can do is to package this into a string. So say you create a string called code. This is now a multi-line string. You package it into a string. So now you have a string representation of the code. And you could either create this dynamically or programmatically in your Python code, so you can add more and more lines automatically. You could create a code project that consists of 10,000 of lines of code created by your Python script and store everything in the string and then compile it down and execute it dynamically. Or you can basically also load any code file. So you can load the textual content of any code file into a string and now compile the string down to a code object. And you would do this by code object, and you would do this by the built-in compile function. Okay, and the compile function it takes some basically the code, takes a string, which is the source, is the code that needs to be executed. Then you have a file name. This is just some meta information. So if you compile from a string instead of a file, you would just add some descriptive string here that describes where does it come from. Basically, this is like the location you can say of this code file. But it can have any value. It's just a representation issue. So it's just if you later print the code object, you will see this representation here. I will show you in a moment. And then the third one is the mode you are using. If you have multiple lines of code of statements, like here, you would use the exec mode. If you would just create a code object that consists of a single expression, you would use the eval representation mode. Okay, so these are two modes you would use, exec or eval. In most cases, you would just use exec. And now you have a code object. Now you can print the code object. It doesn't really have a meaningful representation, but you now see file string. So this is why you need to define the file string. Okay, so this is what we have put as a file argument into the compile function. And so what is the purpose of the compile object now? It is most often used to be passed into the exec function. The exec function is another built-in Python function that allows you to run any executable code object or any string and run it dynamically at runtime. So now if we run this, we would expect that it would basically take this. So here we have passed the code string into the code object. So Python's already compiled everything, compiled the program into the and stored it in the code object. So now it's an AST object, abstract syntax tree object, and it can execute it. And how does it execute it? By passing it into the exec function. So if you execute this code snippet, then it should actually print the result. So we basically can convert a string to an executable Python program and execute it using the exec function. And doing this, you see that the result is now Bob 33,000. So this is just as we executed these 2 lines previously in the beginning of this video, we are now executing those from the compiled object here. So this is how it is used. And of course, you can also pass the code itself into the object function without compiling it. And you see the result is the same. And so you may ask, what is the advantage of using the compilation method? And the reason is simple. So for example, if you want to execute this code for I in range 10, if you want to execute it multiple times, the same code, you could do the following. And now, if you do it like this, if you pass a string into the exec function, it needs to internally compile this string to the code object 10 times. So we have 10 times the compilation overhead. So if you run this, it is quick, but it's still 10 times overhead. If you would execute this 1,000 times, it's a lot of overhead. And you can basically instead just pass a code object and save 10 times, 100 times, 10,000 times the compilation overhead. And if it is a large code file, the compilation also will take a lot of time. So therefore, you could save it. And yeah, this would just improve the speed of your application. Okay, so this is like 90% you need to know about the compile method, the compile built-in function, and you can also check out my full tutorial on the blog. I will give a link in the description below, and maybe just scroll down if you watch the video on the code tutorial, and also make sure to subscribe to our free email newsletter where we actually educate new Python coders and intermediate Python coders to become masters in their field, to improve their skills over time by sending them a series, like an infinite series of code tutorials day after day after day, and they can click and decide themselves which code tutorials they want to have. So it's the most comprehensive, most thought out email academy in the Python sector worldwide. So check it out, check out the free email academy. I give a link in the description below. Also check out our other resources. So Thinkster has a lot of coding resources. Thanks for listening to this video, and see you in the next video. Bye.
What's up, engineers? So there's always a ton of confusion around different types of compilers and interpreters and bytecode and how all that fits together. So in this video, we'll try to simplify all of that. We'll look at ahead of time compilers, JIT compilers, interpreters, and then languages that have compilers to an intermediate representation. We'll talk about how all that fits together, maybe some fun facts along the way. So let's get into it. Just a couple pieces of terminology to get out of the way before you begin. I'm going to use the term AOT and JIT a lot. When I say AOT, I'm referring to ahead of time, and when I say JIT, I'm referring to just in time. We'll start with the ahead of time compiler first because it's the simplest one out of all of them. The purpose of an AOT compiler is to take human-readable source code and convert it to machine code that your CPU can understand. And as the name suggests, it's going to do this ahead of time before your program is ran. This compilation process will always produce a single native executable which you can then run. A few examples of languages which are implemented using this type of compiler are things like C, C++, Rust, and Golang. Next type of compiler is the JIT compiler, and this is a lot different than the ahead of time compiler in that a JIT compiler is not something that you as the user use on a source file. Just-in-time compilation is going to be an actual feature of an interpreter for a given language. So once you execute a human-readable source file with a language's interpreter, that's when the interpreter will decide when it's time to just-in-time compile that source into machine code. So you might be thinking to yourself at this moment, well, if the language interpreter is going to compile the code to machine code while it's running, why not just compile it to machine code before it runs? And the reason is because languages that are implemented using interpreters that use just-in-time compilation are often languages that have dynamic and loose typing. And it's because of this dynamic and loose typing that it's not suitable for ahead-of-time compilation. Take the simple Python program, for instance. The reason this cannot be ahead-of-time compiled is because the size of name is not known at compile time. However, if it were to JIT compile it as it's running, it would first execute this because it does know the length of this string. It would ask you for your name. You would type it in. At this point, it would then know the length of name. It could then allocate the memory and assign it to the name variable, which you could then print. The whole purpose of JIT is to compile and execute things at the very last moment possible. And remember, it's worth mentioning that all this is necessary because your CPU only understands one thing, and that's machine code. Your CPU has no knowledge of Python or JavaScript, C, Ruby, PHP, or otherwise. A couple examples of languages that are implemented using a JIT compiler are newer versions of JavaScript, Ruby, and PHP, and then also the PyPy implementation of Python, which, by the way, is not the default. The default for Python is CPython, which does not use JIT, but we'll look at that a little bit later. Next up we're going to look at is just pure interpretation, and we need to make an important distinction here between this and an interpreter that uses just-in-time compilation. For the most part, any language that's not ahead of time compiled is first interpreted and sometimes just-in-time compiled. So in the context of this next bit, we're talking about languages that are just interpreted and don't implement JIT at all. One important property of pure interpretation is that compilation never takes place and conversion from source code to machine code never occurs. What does occur is that the interpreter will interpret the source code and then produce the desired results using its own facilities within its interpreter. So if the interpreter reads a source file that indicates it should print something, it doesn't convert that print statement to native machine code. Instead, it uses the interpreter itself to just print something. PHP is perhaps the most well-known major example of a language that was implemented entirely with an interpreter up until recently. Although there's still plenty of use cases for interpreters today, they're largely being phased out in favor of JIT compilers simply because JIT compilation is faster in the long run. The last compilation process we're going to talk about is a compilation to intermediate representation with or without JIT using an interpreter. I know that was a lot of terms, but that's because the lines are really blurred between all the types of compilers with this compilation process, but just bear with me, we'll talk through it. The first step in this process is to take human-readable source code and convert it to bytecode prior to running the program. And the reason this compilation process exists to begin with is to decouple the language from the execution environment. This is how Java handles its compile once, run anywhere kind of motto. Java code is first compiled to Java bytecode. That bytecode can then be ran on Java virtual machines, which convert the bytecode into platform-specific operations. And when I say platform-specific, I'm referring to Windows, macOS, Linux, and so on. By doing this, a Java programmer doesn't need to concern themselves too much with what platform they're actually developing for. They can just develop one source code for all of them. This is different than, say, a C programmer that has to take special care in certain circumstances to make sure their code is portable across all platforms. As far as the bytecode interpreters go, they're going to execute the bytecode in any fashion that they wish. And these interpreters are going to be very intelligent. They may or may not use JIT compilation when it's appropriate. In some cases, the interpreter may just execute the bytecode directly, or it may convert the bytecode into machine code and then execute that directly. Exactly what it does is entirely up to that interpreter. Some example languages that use intermediate representation are Java, C#, C++ when it's with the Microsoft .NET framework, and then of course Python using the CPython implementation, which is the default. Now note that C++ was also in ahead of time compilation, and that's because with Microsoft they're able to convert C++ code into intermediate representation, which can then run on their runtimes. This is different than compiling C++ with something like GCC or another compiler. So just to summarize everything again, ahead of time compilers will compile the code ahead of time before the program runs. Just-in-time compilers will compile code at the exact moment it's needed. Interpreters won't compile the code at all. They'll just look at the source code and then produce the desired results. And then languages that are implemented with intermediate representation will convert their source code into bytecode, which will later be interpreted by an interpreter, which may or may not use just-in-time compilation. I know this was kind of a complex topic. I hope I was able to explain it in a way that made sense to everybody. If you have any questions about anything you saw in this video, please be sure to leave them below in the comments. And other than that, hope to see you on the next video. Take care.
Alright, it's another 1 hour and a half. Look at something else to play. I'm gonna test before removing this thing. See if it's gonna change anything. Oh, doesn't change anything. The downside of doing like this is that I think that a loop costs more than the delete operation, but I'm not 100% sure. But I think delete is probably O1 and loop is ON, so I think it's worse, but let's see if it works. No, I don't know actually. I think. Oh yeah. It is the key, I think. Maybe that's what I'm getting wrong here. Because I don't remember what local variables have. And I'm printing this thing here. Oh, but I am printing local variables. Yeah, so it should be the key. Yeah, I don't get it. Maybe I'm... No, but should be confusing two different things because there is the value here. Or the key. Which is this one. Maybe it's because I have this function inside of this one. But I don't see how this would stop the deletion to work. Or the conditions should not work here. But maybe it's a bad idea to leave this function inside of here anyway, so. The issue is if I don't leave here, I think I need to declare this function after this one, but then let me think. Code puts, and the problem is that I need to declare first because it goes here, but then I will have to remove this and make it global variables. I think this wouldn't fix the thing though. We would just move them from local to global. But probably wouldn't fix because I don't see why or how this is related to the conditions not working here. You should be removing these values based on the keys here. So I don't get. I think I'll do it the other way, since this one is not working. The other one at least was removing some of them. And then I think I'm gonna remove this function from inside of this one and make the other one global, have global variables. Yeah, the tree that I can't remove. Unless I pass the tree as an argument. Then I create the tree on the other file. I think I'm gonna do like this for now. There's also no, I'm gonna comment this, right? Yeah, obviously now it removes, but the other ones are still probably on the global scope. At least this one works. I wasn't sure what was the thing there. Like a bunch of modules. And then there was some error messages. I thought there might be something wrong, but it was just the built-in modules in the global variable. Yeah, now it doesn't remove this one. Actually, it's not working for any of them, I think. Oh, obviously, it's because I'm using a leaf. So dumb. I'm just only gonna run for the first one. Damn, that's why it wasn't working. And then it was working for the other one sometimes because probably it didn't have the elements, so it didn't test. Yeah, damn. A silly mistake. I'm pretty confident that this is the issue. Man. It's probably this one. I don't understand this exception here. I think this one is because I don't have the globals. So it can't append, but that is kind of weird as well because it was working before. But I think it's because I had on the function. Because this functional was inside of the other one, but it's still kind of weird because it was outside of the scope. I think I'm gonna remove this class here as well. Probably not gonna use this. So it's probably an issue here, but also weird that because this exception as well. So how would you give me these exceptions if the mistake was here? Doesn't make sense. Name Cs is not defined. Must be on the conditions here. It's probably because I'm calling the function from the other file, and I'm importing on this one. But it's kind of weird because it should be importing on this one. No, but I guess because I'm putting there if name equals main, might be there. It wouldn't give me a mistake here before. Maybe something else. It's kind of weird because I think it was working here. Like I don't declare the variable anywhere. The one that I'm appending to. But again, this function is inside of this one, so maybe it's still on the scope because it's non-local and not global. Even though I have to declare the other ones, I don't declare this one. No local. So that error is probably that, but then the C's I don't understand really well what is going on. There's probably something with scope as well. So it wasn't this. So it must be here. But it's weird again because I'm checking first, so don't understand. Yeah, this is this exception, and then this one triggers the other one probably. Maybe it's this thing here. Yeah, I have no idea. Because when it hits here, it might go to the other file. So let me go back to the way that I was doing before, see if it fixes. Go just putting this one inside of the other one. The fuck is this music, man? It must be because of this skull. I think it has to do with something with the imports, and because here I'm using if name equals main. On the other file I'm just calling the function, so but it should import the libraries, I think. Or maybe it doesn't import because I'm putting this. But then why would work before? And if that was a problem, then it would be messing up here. So it might be because of the way that I'm deleting here, but that's kind of weird as well. Because otherwise, like, the check wouldn't pass. Now let me try like this. Yeah, it must be because of the... So let me delete this and see what happens. Is it... No, it doesn't break. I mean, it's probably because I'm deleting from the global variables and then it fucks up the execution. That's why. So I have to create another object, I think. So I don't mess up with this one because it's gonna fuck up the execution. And that's the issue. Well, let me worry about the local variables first, then I'll think about this stuff. I think I'm gonna have to close this terminal, probably. Yeah, it doesn't work. Yeah, so probably this one is also bad to do like this, if that was the error. Finally. Damn, what a silly mistake to make. So let me think now. I think I guess I'm gonna put something different here because I was having the problem with the other one. So I'm gonna check importing modules now, what happens. But first I'm gonna try this one. So it looks like it works. I think I'm not gonna worry. Actually, yeah, it might be better to do this in another way. I think like the way that it happens is because this function is triggered after the execution of each stack frame. So if you mess up directly with these values, you might screw up the execution of the script, because when it's going back, popping off the stacks in some cases or whatever might mess up here. Not sure. Yeah, this one I did it directly because I was just building to debug the script, so I put the names directly, so I did not have this problem. Yeah, so create another object. I guess that's something else that I can do. Instead of making a bunch of conditions, I just put everything into an object or a set, and then I check. Just see if it is there or not, and if it isn't, then I add to another dictionary. But I'm gonna have to loop anyway, I think, over the local variables. But I think before I'm just gonna leave it like this, and I'm gonna first have to import. Then I'm gonna focus on building the graph visualization first, then I worry about cleaning. It looks like it works. So it starts here. No. Yeah, this is the issue. For each line, I guess it's not an issue. It's part of the script. It's gonna be cleaner when on the visualization because it's gonna be each one is gonna be a node, so you're gonna be able to follow the lines. Yeah, I think this is fine. So maybe you should put a float. I think this is another thing that was messing up the other time, and I didn't know why, so I'm just gonna use one of these functions here, probably this one. Yeah, now it works, nice. So frames here and it's working. So it did execute. Now obviously this is very simple still. Thing is, decorators are functions, so I want to test what happens if I pass a decorator, but I need, and also classes, things like that. But I need to think about a good example. I think I'll probably do this maybe off stream, maybe tomorrow, because I'm already tired, to be honest. I think for now I'm gonna test this one, and then if it works I'm gonna see how I can structure the data. I'm probably gonna, regardless of the way that it's gonna be, but the extra complication is gonna be if I have additional lists inside of the dictionary, but it's probably gonna be a list of dictionaries, the main data structure, and then any additional information is gonna be a value of a key of one of the dictionaries that I wanna pass. And to make the visualization better, I'm gonna have to study the documentation as well, because I wanna be able to capture the stuff that you can't see on the source code. Like, I need to make a list of everything that is abstract when you're running a script that you can't directly see what's going on, like variables being passed around between functions in different files, and classes. So I think a great example of this is the editor here. the editor and the Vue.js thing highlights what I want to achieve, I think. Yeah, so for example, or maybe it's not this one. Yeah, it's the view that I want. So on this one, for example, where there's a bunch of different classes here highlighted, which makes it a lot more difficult to understand what's going on when you're calling a method or something, because like these configurations are passed around, and then like this one is used inside of here and then here. So if you're gonna look at this manually, going file by file and function by function, it just takes a lot of time to remember like what was being passed around and how like that is working. And sometimes it's like this. I think here is a great example where like it's really difficult to understand what this is exactly. Then the other one, I guess the state as well, this one. So I need to make a list of everything that is invisible or very difficult to keep track of if you go manually, function by function or class by class, and then just put all of this stuff on the visualization while at the same time having some stuff that is visible, so that you anchor what is invisible with what's visible, and then it becomes a lot easier to navigate through everything because you can see like exactly where the information is going. The other challenge is being able to map this stuff on the server with the files that people are gonna have locally on their computer. But it's gonna be like something trying to figure out the relative paths. Maybe it's not that difficult. Yeah, so here I think I'm gonna uncomment this stuff. And then on the front end I'm gonna receive. Oh, the other thing that I wanted to change here is the order that I'm doing this. I think I'm gonna pass the graph first, because I just realized later that the data might change, the way like what I'm passing as data, but the graph is very likely to always stay the same. So it's better to put the graph first, because if you wanna put the data directly here, for example, might be more annoying, but I think it doesn't make a lot of difference, but this is slightly better. And then here on this file I'm gonna create another function to visualize. I should change the name as well. Because I'm gonna have multiple different visualizations. So what can be the name of this one? Execution. Fuck. So let me think. Yeah, I have to change here first. Or maybe not. Yeah, maybe not. Actually, I'll just change the name of the function. So I receive back a list of objects. I think I'm gonna copy for now. Fuck. I'll copy this stuff here in the back end. I was thinking about the reason why I put this stuff here is because I was thinking about returning the errors, and I was like creating a flag variable, and then if there is an error, an exception, then during the execution of their script, then I send the nodes and I make the colors red to show that there was an exception. And this is something that I'm not really sure about, because Python tutor does this, but they do it with a warning. So, but the thing that is tricky is that, like, differentiating an exception from my code and from their code, and then whether or not it's worth sending, or like I could just send something. The problem is if you send something generic, then like it might be an issue because people, it will be annoying for them to fix the code, because there's not gonna be any details on what can be wrong. But I could just send like a message, or I can send an exception as a response. I could do that and then highlight in some way. And then maybe I create a flag variable. The reason why I'm thinking about this now is because I'm not sure how I'm going to return here. because I'm not sure if it's worth to create the graph visualization of just the error. I think it's not that worth it, to be honest. I think it's not worth it. And this is just one of the types of visualization that I'm gonna do. I think the one that is gonna be most effective is probably not even this one. Is like I'm gonna have to create something, probably using the AST to parse files and folders from projects and then create connections and like make the analysis of what functions are used most often, that kind of stuff. But that one's gonna be harder, that's the problem. So that's the reason why this one I think is worth doing first. So I think I'm gonna remove this and I'm just gonna do just gonna return this thing here. But maybe I should return the exception. I guess I can just I return this stack frame if and then if there is an exception, just return the exception here. And then I check on the other one to see if it's a list. And depending on whether or not it's a list, I will return something different. I can return failed, like I have here, and then I put a condition on the front end that if it is fail, it shows something else. I could put a div or something showing a warning. Shouldn't be hard to do. I think it's always going to be a list, regardless of what data structure I decide to put inside. I'll probably have different endpoints as well for different visualizations. I think that makes more sense to just send fail here, I think. Oh, actually, it's better to leave this stuff. Oh, let me think. I should send it as a dictionary. Maybe you should always send it as a dictionary. Oh, actually, I have the status, so I do it with the status. Because I'm gonna want to choose send anyway. The frame, because I'm gonna send the message of the exception. I should probably make other messages, yeah, on this one. The thing is, okay, if it fails here, I'm not really sure what is gonna happen. So I think I just have to put test the inputs. This kind of stuff is kind of annoying. I think I'll do it tomorrow. So I have to do a bunch of different inputs, then test for each exception here, and then see what happens, because for each exception, like, I'm gonna have to send a different message. In the same way that they have on Python tutor. But I think here should be the E as well. And here just return fail. I think it's better to just put failed here. So it only sends, I only call the other function if the status is okay. I think I will have to think about this later. Because I will have to make a message here, like I'm gonna put a condition. I think this status here is not the same as the one that I'm sending there. I'm sending, it's part of the object itself, so I'm gonna have to put an additional if statement here. And then based on the, maybe I'll use another use state variable, and then I change the value based on whether it fails or not. And if it is okay, then I return the data. If it fails, I return, or I set the flag variable according to whether or not it fails, and then with that flag variable I change here what is gonna happen. If it is okay, then I set everything, and if it isn't, then I send a message. I create a message, and or I make the div based. I put a div here, and then I make it based on the condition of the variable. Yeah, I think that's the best way. But I don't want to do that now. So I think I'll just focus on this one. His music is not very good. So let's think now. So obviously I'm gonna loop over the data. And then what? How do I connect everything? You can just create a label and then put the information on the node. And it's just simple as that. I think I should actually connect the local variables with the file name, and then connect the file, each file name with the other one. I need to keep track of the or append to another list, to another array, I think. Because the other one is gonna allow me to connect each file with the next one. I have to loop over the local variables thing. Maybe it's better to also like try to extract before I do this, to try to extract something that is more readable than this stuff here. See if I can. The problem is that I guess I can do an if statement to see if it's a module or not, and then see if there's a way to simplify this. I think that's what I'm gonna do. But here I'm gonna probably use the object.values. Let's do that now. Oh, maybe it's more. Don't know if I can map directly.
I'm calling out your name. I'm calling out your name.
And then here I add the node. But the thing is, this should add the frame node first, the file node first. How I'm gonna connect the... I think at first I'm just gonna connect all the information for each frame. I connect the file with the information from the file. And then connect the different stack frames. Then I'll think about the rest. I think actually it's probably better to optimize this later. Once I have the main thing is to optimize the graph first. That's also the thing that has the most uncertainty, I think, because of the way that Next.js updates the state and the canvas, and whether or not it's gonna be like, I need to know what is the limits. Like when using Pixie.js, what's gonna be roughly the limit of nodes that will make the graph very slow and unusable, because by knowing that, then I'm gonna be able to know what direction to go to structure whatever visualization in the best way possible. So I think I just do the simplest thing that I can imagine here. Just create the nodes for each frame and connect everything to the nodes, and then connect the files together. So I'm mapping over the values in the local, so gadd node. Or maybe I should just...
Same place, seen you in the right place, when you getting out this space. Seen you with the same maze, when you gonna let shit change, when you gonna use that brain. I wanna sing a shit mate, pouring all in that spade. Should've worked to my back bay, shovel dirt in the back lane. Oh, I'm home in the black pain. What's the price of the small change? Tell them that I'm okay. This phase, you gonna say I'm great. Questions I need to be asking, I need you
line number function. The thing is that this way, I guess I can just, I was gonna say that I'm going to link them backwards, but I think it doesn't matter because it's undirected, and also I can just switch the way that I do the edge here, and just switch the nodes. I think I'm gonna do like this, and probably it doesn't matter. If it was, yeah, maybe doing the other way is better, because if it was reversed, I think it makes more sense to connect the previous one to the current one. I think that's it.
That flow through you. I wanna be thrown into your tide. I wanna become like you and move the way you do. I wanna be thrown into you and go wild. Sirens flicker around your head tonight. You can see them calling for my silent hands to come alive and to tear this wall. And sirens flicker around your head tonight. Let the sound come down on you, down on you. Oh, oh.
Don't understand why though. I'm just gonna comment this out.
I just wanna turn into the darkness that beats in you.
I'll also have to fix the thing when it updates, so that is it doesn't add additional nodes and just resets the graph. Because this should be a list, and I'm passing. So here you should be receiving a list and then going over the function.
Sirens flicker around your head tonight. I can see them calling for my silent hands to come alive and to tear this wall in. Sirens flicker around your head tonight. I can see them calling for my golden hands to come alive.
Yeah, it's a list of objects. There must be the return statement there. Oh, that's the problem. It's because of the ID. Oh well. It's because I'm adding the wrong way. Here somewhere. Yeah, each one of these is gonna be an object. But it should be capturing the values. Oh no. It's also weird because all of them are the same. I think I'm just gonna train typing for some time and then stop here because I'm already tired. I'll figure that out. But I'm almost sure that the problem is on the way that I'm putting the nodes there. Because I'm messing up the ID and then it messes up the components. But I think it should work there. And then after I fix this, I'm not gonna I think the first thing that I'm gonna fix is actually what happens when there's a lot of lines there, because it creates a different structure. It becomes an array of nodes instead of just one array on the editor. I think that's the first thing that I wanna fix. Then after I fix that, I'm gonna work on the visualization. I think I'm just gonna do another component and try to use the Pixie library to make the visualizations, add a physics engine, and then put event listeners. I think it's gonna be very difficult, so I think I'm gonna stop here. So I'll probably come back tomorrow. Tomorrow I'm gonna stay for less time because there is a live stream from Buildspace. I'm gonna watch that probably. So, but I'll probably come back tomorrow and continue to do this. So see you then.